Hello, welcome to the last day of ICNS 2025, the 25th edition of the Integrated Communication, Navigation and Surveillance Conference. Yesterday, we started off with the welcome remarks of SDM's Executive Director, Maria Grazia. Then we heard really the reassuring speech that at policy level, the CNS aspects are understood and prioritized from the head of the European Commission Single Sky European Unit, Floor. Thank you very much for that, Floor. And you need to remember the engagement. In 4 years from now, you need to come to the next ICNS in Europe and see what happened in these 4 years. Then we had 2 more great panels with Paul and Vojislav. And in the afternoon, we had 8 parallel technical sessions from the 6 technical tracks of the conference with 63 technical papers, 3 more than the day 1. Then we closed the day with an engaging speech from ESA's lead astronaut, Luca, who highlighted that for the space, like for aviation CNS, technology is not really the showstopper. We concluded very late, and from what I understand, some they have not still come to the conference from yet, and they are unaccounted, with a superb 25-year anniversary celebration sponsored by our host SAU in the Regal Bellevue Museum. We had there a welcome from SAU's Executive Director, Andreas, and we had also the announcement of the winner of the ICNS Champion Award, which is Paul Bosman, EUROCONTROL's Head of ATM Infrastructure Divisions. Congratulations, Paul. What I want you to remember also is that it is you that you make the nominations for the ICNS Champion Award. So keep that in mind for next year, for 2026 ICNS, and do nominate the people that they think that they deserve the ICNS Champion Award. It was really a remarkable day 2 yesterday. So moving on today, I want to thank all of you again that you came to the EUROCONTROL headquarters in person, and I also want to thank all the ones that actually joining live all over the world through the EUROCONTROL's live stream, and also those that they will be seeing actually this on playback at a more convenient time of the day. So I think I said a lot, so without further ado, I want to invite actually again Andreas to give us actually the opening welcoming remarks from the third host. Thank you, Andreas.
Good morning. Thank you, Nikos. I appreciate the early birds, the brave ones who made it on time for the third day. Actually, I enjoyed very much yesterday evening the networking dinner with many of you. It was the opportunity to celebrate the past 25 years and the future 25 years of ICNS. And it's a pleasure also today to speak about a topic that it's very much at the heart of air traffic management. CNS. CNS doesn't capture the headlines, it should not, but all of us in the room, we know how important CNS is as invisible infrastructure. It underpins everything we do in aviation. We need reliable, secure, precise, scalable CNS. And as we look to transform European airspace in line with growing traffic demand, environmental imperatives, and digital innovation, CNS must evolve. And this is why we, within the SESAR Joint Undertaking, we do not treat CNS as a technical afterthought side thing. No, for us, it's a strategic enabler. And we have addressed it head-on through a coordinated, forward-looking CNS roadmap embedded in the European Air Traffic Management Master Plan. And this CNS roadmap sets out a clear trajectory how to modernize Europe's CNS infrastructure. It is based on few core principles, and I have 7 to list now to you. Number 1, integration and efficiency. We move from siloed systems to an integrated, that's the name of the conference, integrated, performance-based CNS infrastructure that can support more connected and automated operations, both in the air and on the ground. Number 2, performance orientation. The roadmap adopts a performance-based approach. It focuses on the operational outcomes and the user needs rather than on prescriptive technologies. And this is aligned with our target architecture and our new service delivery model. Number 3, deployment of advanced technologies, more spectrum-efficient communication systems, satellite-based navigation capabilities, enhanced surveillance solutions such as ADS-B, multilateration, and yes, increasingly space-based surveillance. It was good to have an astronaut talking to us yesterday also to bring space closer to our conference. Number 4, rationalization and decommissioning. The transition to next generation CNS solutions must be accompanied by a phased decommissioning of redundant legacy systems. This is crucial for reducing operational costs, complexity, and also spectrum congestion. Number 5, and you discussed it yesterday, I heard, cybersecurity and resilience. With increasing digital reliance comes the need for robust, secure CNS systems capable of withstanding both technical failures and, unfortunately, in the world we are living, malicious attacks. Global interoperability. We have to align with ICAO, with international standards. This is essential to ensure that European solutions are fully interoperable and contribute to a seamless global aviation system. And number 7, the last one, implementation. We need implementation. And the implementation of the roadmap is now supported by the newly released CNS evolution plan in coordination, of course, with EUROCONTROL CNS program manager. Good to have them with us. Through our Digital European Sky program, we are working to develop, validate, and accelerate the deployment of next generation CNS solutions. So I'll give you a few examples. Communication. We are exploring the deployment of L-band digital aeronautical communication systems, LDACs, as a complement to existing data link solutions to ensure scalable and secure air-ground exchange. In navigation, our projects are enabling performance-based navigation and the increased use of GNSS, supported by technologies like GBus and SBus, to improve accuracy and support approaches in all weather conditions. And in surveillance, we are advancing ADS-B and multilateration alongside studies into the potential of space-based surveillance to extend coverage and improve situational awareness in high altitude and remote areas. And I have to mention it again, exciting news on 15th of March, the first SESAR project satellite was successfully launched aboard SpaceX Transporter 13 mission. That's a major milestone for us in advancing low Earth orbit, LEO, satellite technology for aviation. A second satellite will follow shortly. I discussed yesterday, June is the target date, and together they should demonstrate the potential of LEO satellites for VFH communication and ADS-B surveillance in remote and oceanic regions where ground-based infrastructure is limited or non-existent. And this is an international project because these pioneering tests will assess pilot controller communication across areas, including, and now it comes, Cabo Verde, Canarias, Azores, Santa Maria, Dakar Oceanic, and the Brazil Atlantic region. This is a European project with an international dimension, clearly. Implementation of the CNS roadmap requires coordination between manufacturers, ANSPs, regulators, airlines, institutional players. It requires investments, common planning, and a political will to retire the outdated systems and to embrace the modern ones. And the European Air Traffic Management Master Plan plays a key role here. It gives us a strategic reference to which we all agreed in Europe. And for the first time, it helps aligning research and development with deployment. For the first time, we are having deployment priorities identified in the master plan. So with the master plan and our ambitious R&D efforts, we are laying the groundwork for the future of air traffic management in Europe. Safe, secure, greener, smarter, more connected. And we are working closely with ICAO and our partners in other regions of the world to ensure that our approaches are coordinated. I invite all of you, whether you are in Europe or elsewhere, please continue engaging with us, with our projects, with our members, to contribute to the evolution of CNS and to help us make our skies safe, efficient, and environmentally friendly. It's now a pleasure to continue on the international side and to introduce Pascal Luciani. Pascal, after working for the French administration and also having been in Brussels as French aviation attaché, you are now with ICAO. You're the deputy director for A&B. You told me yesterday you have a lot to say, and I know you are a good talker, so I'm really looking forward to your keynote speech. Thank you very much.
Thank you very much. I'm delighted to be here back in EUROCONTROL, which indeed I have known in a previous life, and to speak in the name of the International Civil Aviation Organization regarding a very important evolution of ICNS. I had some slides. I don't know how they.
Sorry.
Yes, I had some.
You're right. I think it must be.
Okay. Okay, I'll start speaking, and the slides will catch up at some point. Oh, there they are. No, they're in there. Okay, so I'll start speaking. The first question, and without the slides, I hope I will be understood as well. The first question you might want to ask me is, well, why would we talk about the prerequisites for harmonized CNS for the future? After all, aren't we past this? Aren't we at a stage where all the prerequisites are states and it's just a question of implementation? Well, that's not the case, because as we moved forward in the previous years, and maybe the last one, we've seen the foundations on which we were thinking we were relying are slipping under our feet and moving away. And we've seen new challenges that have been coming up and that are becoming major hurdles on the way to progress of CNS. So let me first list the threats, and I know you know those threats that are coming to us. Security. Security has been a major threat that has been identified. Traditionally, threats against airplanes were threats against the physical airplanes, bombs and others. It's not until recently that ATM, that communications, that CNS are viewed as tools that could affect the security of aircraft. And we have to factor this in. We have to factor this in because we have to be anticipating, and we have to be making sure that none of the worst case scenarios that we have are going to happen. We have the increasing frequency dependency on cyber security. We have GNSS, the spoofing and jamming. A few years ago, this was a theoretical concept. Today, it's coming to us. And I hear sometimes, I know you're in a room and you listen at the conversation, and sometimes the words pop up, and I hear spoofing, jamming. And this is something that is on everybody's mind. This is a major concern. This is starting to be a concern in the public, and we have to address this. We have the CNSS services vulnerabilities that we have to address. So how are we going to address this through initiatives? We have the integration that is going to be the integration mechanism that we have to go through. We have enhanced civil-military cooperation. That is a key, even more so today than before. This is a very sensitive topic, but a lot of the actors are willing in all the regions. We've had here some conferences involving NATO, involving others, but in other regions, in Asia, in Africa, in the Middle East, all those initiatives are coming forward, and they are needed so that we foster this cooperation and allow to integrate this question of civil military cooperation in the evolution of CNS. We have the retention of sufficient navigation capacities independent of GNSS. GNSS is offering wonderful opportunities, but at the same time, we need to make sure that we keep the conventional tools that allow us to address the lack of GNSS. We have the implementation of a trust framework, and we have the necessity to rely on roadmaps. So these are all the topics that I'm going to broach on. First, a reminder of the fact that the ICAO Council adopted Amendment 12 to Annex 17 regarding security. So things are moving forward, and those questions are being addressed. I'll also say that Doc 9985 and Doc 8973 are evolving. This is all to address security matters. Let me first start by focusing on the safeguarding of the ATM system for security threats and vulnerabilities. Safeguarding the ATM system is a clear and present danger today. And we know that we don't want to wait for an accident to happen, for an attack to happen. This has to be done through several ways. but technology will play a clear role in this. In addition to protecting the ATM system itself, it's also crucial to provide security services that contribute to broader civil aviation security, national security, and defense efforts. ATM security operations encompass a range of activities aimed at detecting, preventing, and responding to security threats. What do we have in this, and what are the initiatives that we need to develop on this? Well, there are cybersecurity services. There's also, of course, the physical protection of the sites themselves. This is the traditional security, but I think more than ever before, we see each of the knots of the networks of CNS as a potential threat that needs to be physically protected. And there's finally the collaboration with national security and defense agencies. Collaboration will be a keyword throughout much of my speech, and it's a key value of ICAO. And this is something that without which we will not reach integrated CNS, and we will also create dangers for aviation, for our passengers, and for our cargo. So let me say a few words about the cyber resilience. Cyber resilience has two dimensions. It has the dimensions of resisting against attacks themselves. Attacks can be extremely sophisticated. It's the constant fight between the sword and the shield. And we know that sooner or later, we'll be faced with attacks. And the only way to resist them, since we cannot always know exactly what form it will take, is to have the global resilience. And I think, yes, cyber resilience. Thank you very much. This is an area where ICAO offers its services. ICAO expert group are working collaboratively to address these challenges and to protect the CNS system in a coordinated and globally harmonized way. We are going to do this through standards. And those standards are not going to be standalone standards. We have to associate the industry and the industry standard organization. In a little while, I'll be talking about the new arrangements for the standards that ICAO is proposing and that I know you're aware of, and that people I've gotten a lot of positive feedback on this, and we know it relies on industry standards. The standards can no longer be made alone in an annex, in a manual. They have to be there, especially in the field of CNS. And this is where all actors must work together collaboratively internationally. And we're also conducting specific work on ground-ground air and air-ground communication, satellite-based augmentation, and emerging areas. Cyber resilience is not just about, we can move forward, is not just about security. Do I have a remote? Oh, okay, it's here, the green button, okay. It's not just about security, because while we may think that the only danger is a hacker or a terrorist, there's also the complexity of the digital CNS itself. And some of the incidents we've had in the past were not resulting from attacks, but simply the system having failures, the redundancies failing, the redundancy not being sufficient to address the issue. And when we address the resilience of the CNS system, we have also to think about the mechanical, the physical, and the digital breakdowns that can occur. And we cannot only focus on security. In these areas, work is closely coordinated with industry standards bodies. And once again, I would like to mention the essential role of bodies such as RTCA and EUROCONTROL, which are going to be among the key designers. And of course, all the member states of ICAO also have contributions. And all of these need to work together and find common solutions. Without common solutions, we'll have segregated systems. Segregated systems are more vulnerable. The interoperability frontiers are, so we know that are a source of risk, of lack of resilience, and this is where we can start having difficulties. A second area I wanted to broach on is the area of the trust frameworks, with a plural. Now, trust framework is a fairly recent concept. In the beginning of aviation, trust frameworks was not something that would immediately have come to mind. And I would say even when I'm flying as a private pilot, trust framework is if I'm on the right frequency and there's a voice on the other end, well, that's pretty much the trust framework test. The voice is probably telling me the good information and leading me to safety. But we know that with today's CNS, we need to go beyond this, and a trust framework needs to be established. We can only push the digital progress so far. When we start to be out of the reach of what an individual controller, what an individual pilot can master and have a full awareness, when we start to trust the digital system, the trust framework is absolutely essential to protect once again against the cybersecurity threats, against the security threats, terrorist action, but also failures of the system. We need to ensure that the CNS is working correctly. This facilitates protected, secure, and resilient information exchange in the global aviation ecosystem with global interoperability standards for confidentiality, integrity, and availability. The key, this is a key enabler for cyber resilience of CNS systems. There are a lot of difficulties associated with the trust framework, and not all of them are technical. And I wanted to have a word on this because as we move forward, I guess the technical definitions of trust frameworks will move forward, and we'll need to address the political ones. It's not easy to build such systems. We have moved from an initial idea of a big centralized system because we figured out this would not be working in the world where there are so many nations. So it will have to be a juxtaposition of trust frameworks. The question of the interoperability, the communications between this system will be fundamental, and will have also dimensions of national security, national sovereignty, and cooperation. And we also need to address practical questions, such as the financing. We're here, a lot of us are technicians, we're not worried about the financing. Well, some of us are not worrying about the financing too much, but this will be a question. And recently we were confronted with a topic in another field of area, meteorology, where we see that the questions of cost recovery, of who pays, can not only be important, but can become a showstopper. And as we develop trust frameworks, we must also think of those concepts and find agreements beforehand so that the technical progress on which security, safety rely doesn't end up being blocked by political or financial discussions. This is once again a key enabler for the resilience of CNS systems. So we know how it works today. This slide has been projected a few times, and we need to be sure when there's a message received, especially when it's a data message, when you don't have all the verbal cues that you can get, when you don't have the traditional elements that a pilot can use, that this is working. And what happens when you have an invalid message? Well, you have to understand why it is the case. Is it just an error in transmission? Is it an attack? Is it something that the system is not working? And this means that your trust framework will be essential. And we know that for an air traffic controller in the midst of action, for a pilot, the question of timing is absolutely essential. If my credit card is not immediately identified when I go to when I want to buy something, well, I wait for 5 minutes, I call the bank, and I can sort this out. Or I use another card. When you're a pilot, you don't have those 5 minutes, and you don't have another card. So this is what the trust framework challenges are. And without solving these issues, we will sooner or later face a roadblock where we will not be able to keep up, and all the promises of integrated CNS will simply not be able to go forward. And we know that traffic is is coming back. We know that we have more and more congested airspaces, and we know that we need this ICNS. So a second very important prerequisite on which we have to agree. GNSS for aviation. GNSS for aviation, well, in the context where we're now today speaking of spoofing and jamming, let's not forget everything that GNSS has brought to us in terms of safety, in terms of performance-based navigation, in terms of search and rescue operations. Those benefits are huge, and today we cannot walk back on these benefits. So we will continue, of course, to rely on GNSS more and more, but we know also that the challenges are mounting, and that PNT will have to address this as a fundamental prerequisite. Benefits, again, in terms of enhanced safety, increased capacity and accuracy, fuel efficiency, and global coverage. So if I look at the goals of ICAO, of our new strategic plan, pretty much all that we're doing is relying on GNSS aviation benefits. So GNSS vulnerability. More and more in the recent years, we have examined the vulnerability of the system to interference, both intentional and unintentional, and these can compromise the system reliability and accuracy. Jamming and spoofing, I think everybody in this room knows the definition, so I won't go over it. A few maps. We're here in Brussels, so this is the map of Europe. Just to highlight the amount of incidents that can occur and where jamming is something that pilots experience. I would say that there's hardly, I would bet, and probably you'll find a counterexample, but I would wager that there are very few pilots that have not at some point be exposed to some kind of spamming and spoofing. And this means that it's an occurrence that all the passengers are likely to face one day or later. Spoofing also happens, maybe more localized, but this also happens, and another map here of an area where there was reporting. So how do we go about addressing those issues and having resilient PNT? Spoofing and jamming are a very tricky question, first of all, because the states themselves will simply not ban it. In a world where conflict, sadly, is still present and sometimes rising, in a modern warfare context where GNSS positioning becomes a tool of modern warfare, spoofing and jamming are primary tools of military operations, both offensive and defensive. And therefore, no country in the world will ever say, let's ban spoofing and jamming. As of today, we know that there is a direct threat to aviation from spoofing and jamming. Spoofing and jamming are, most of the case, deliberate. The more tricky question is it an attempt to attack civil aviation or not? So we don't have evidence today that it would be deliberate with the attempt to down aviation. But this is something that we also have to keep in mind, whether it's happening today or whether it can happen in the future. This is something that we have to keep in mind. We are aware also that the risk of GNSS interference is not limited to the moment that the aircraft is exposed to it. And some pilots have told me, who have been faced with spoofing or jamming, problem is not so much when you're in that area of spoofing and jamming, because of the energy emissions requirement, that area is small. You're not going to be for 2 hours in most cases in the spoofing or jamming area. But what happens after you've left that area? And the way the systems are designed today, for the next 5-6 hours of your flights, the pilots have a system which has considered itself unreliable, and they're penalized for the rest of their travel. The air traffic controllers also see this aircraft coming with a big warning label that GNSS is potentially unreliable, and this creates problem of lateral vertical separation. So this is also one of the areas that we have to look into. So the resilience post fact. Solutions are certainly, first of all, the reporting. Reporting is going to be key. International organizations, airlines are all cooperating for the reporting to be as fast as possible. We know today the dangers. And all the pilots are aware that GNSS can be a potentially contributing factor to accidents. We haven't yet had an accident that was directly linked to spoofing and jamming, but we know it can be a contributing factor, and we know that Swiss cheese theory, so we want to avoid this as much as possible. And in that, cooperation between the airlines within the civil aviation area, cooperation with the military authorities are going to be crucial, and balancing the needs of the military sites and the civil aviation are going to be a key progress. This is not going to be an easy task. In terms of technical tools also, we're working. So if we were moving towards a resilient PNT, we have the complementary PNT, the CPNT, which is arriving, the concept which was introduced through A41 BC. We are going to use inertial sensors, DME, to be most suitable near-term solutions for mitigating those GNSS RFI. And that means also going to making sure that we have on the ground the networks that can support continued means of vectoring, of having BORs, DMEs, and others, where that the pilots can rely on for the short, hopefully short durations that they're under GNSS spoofing and or jamming. Then there's the alternative PNT of APNT, providing guidance as appropriate to maintain safe and efficient operations in case of GNSS outages. This is the resolution I was referring to about the resilience of GNSS. ICAO policy on GNSS directly addresses both jamming and spoofing. And if you can read it, you have very good eyesight, but I will leave it as a reference. The presentation will be distributed after this. So we have to build that framework for GNSS and aviation resiliency. We need to know where aircraft are affected by interferences. We need to understand what GNSS-based service can no longer be used. We need to understand the aircraft operational impacts. A lot of this will be acquired also by the experience, and we must work together to address aviators and flying public safety, security, and economic needs, and address each individual interference, jamming, and spoofing events today. I would also add that there's the taboo on spoofing and jamming is starting to be removed now. It's something that we can openly talk about. It's something also that the public is ready to address in a mature and technically sound way, so that we're ready to move forward on this. Evolving standardization, I mentioned it at the beginning of my speech. Innovation starts at the flight deck, and the people are going to be the key in moving progress forward and evolving the standardization itself. Another very important area is the integration of the drones, of the various service, the high altitude platform systems. This is one of the key challenges that we are facing today. And I was yesterday watching the technical presentations, and we see the change of scale that is being brought about by the drones and the operations. I'd like to remind, and I know all of you are fully persuaded of this, the inevitability of the arrival of the drones and RPAS. Whether we want it or not, they are coming. And I am quite persuaded that the new services, the drones, have a potential to provide to such a large part of humanity in terms of internet coverage, in terms of surveillance, geographical activities, safety, saving efforts of labor and maintenance of life. The impact on the population is so big that it's going to happen whether anyone wants it or not. The scale also. It was very interesting to, and that's not something you had 15, 20 years ago, to see how the new integration of drones is viewed as pushing the limits of the computation. We had, I remember when I started working in aviation, we had the workload of the air traffic controllers, the workload of the pilots, that was the limit. Computers basically had a lot of work power. Today, we're testing the physical limits and the digital limits of computation, which can be solved through better equipment, better software, but this is where we're going. And the list of those activities is ever growing. We have drones, we have urban air mobility, we have the near space vehicles, more and more of them, and even space tourism. So space tourism today, it's a few billionaires, but maybe in 50 years, this will be as common as today it is to go to the Caribbean or to go to Australia. And if that's the case, then this is going to create also a huge impact. The big question is, can we keep up? Not do we want to keep up, but can we keep up? The new entrants introduce unique operational and regulatory challenges that must be addressed to ensure the safe and efficient airspace integration. And this is going to be one of the prerequisites that we have to address altogether. A few images of what it means, the safe, secure coexistence. And so interestingly, there's this image on the left. And the question is, how do you interpret this? And I would say that 5 years ago, people would say, oh, it's a very dangerous situation. The drone is out of control and this airplane is in danger. And today you would say, well, this is an example of integrated operations where you manage to have a drone integrated around the airport circuit, and nothing is being, safety is not being endangered. And we hope that in the future, having a drone near an airport is just viewed as a normal operation, perfectly safe, and not a dangerous drone that, of course, is operating within the work of the airport. And we have on the right the airplane. If that airplane had been flying 5 years ago, 10 years ago, it would have been absolutely alone. But now this private airplane has to countenance with 10 other drones that are flying in the sky, and the pilot has to somehow make his way. And with the new systems of CNS, if we manage to build it, this will be as safe as when the sky was entirely free. So what are the other big challenges that we face? The spectrum challenge and the institutional challenge. This slide, I have to say, is exactly identical to the one I presented last year. It's not that I lack imagination, it's that the situation is still the same. Spectrum challenge, I would say I love the sentence that Luca Parmitano said yesterday, and we can adapt it to the spectrum. You're either at the table or you're part of the menu, and aviation is in that situation. We're a very appetizing menu for a lot of very legitimate providers of services in telecommunications. And if you look at the number of people with their iPhones in the metro and the street, there's a demand for that. We don't want to be on the menu. We want to be at the table. We want to remind that we are credible actors. And this will require both being defensive, but also being proactive. We can only be defensive as much as we prove that we have gone to the maximum of what is technically feasible to manage our safety spectrum efficiently. Institutional challenge, there is slow adoption of new technology across the globe. The regulatory framework is needed to accommodate the accelerating pace of innovation. And this is where on the ICNSS road ahead, we have this new standard philosophy that we're proposing, and which is much thinner standards. And if the basis, the bones of the standards are thinner, well, the flesh needs to be provided somewhere else, and the flesh is the industry standards. This is the vision that we have. It will be more agile, it will be more flexible, and this is how we move forward in this context. Another key area, roadmap. Yes, and thanks for reminding the existence of the roadmap. There are other roadmaps also in the world. We need to have roadmaps and a global roadmap. So roadmaps, it's a very nice word, but it's not just a word. It means that we are, with a roadmap, we're making decisions. With a roadmap, we're not pushing forever decisions which can be difficult. And with a roadmap, we give certainty to the industry, to the stakeholders. This can of course only be managed collaboratively. No roadmap can be dictated, and if ICAO, the Air Navigation Bureau, or any individual country tried to impose a roadmap, this would not work. But together we have to be conscious that time is running up, and that if we don't have clear goals, clear milestones in the future, we will be forever stalling, and we will not be moving forward. So the roadmap is based on leveraging the recent state-of-the-art advances in CNS technology, ensuring that aviation remains a responsible user of spectrum. I've went into that, focusing on safety, security, efficiency, and sustainability as well as of global aviation. This is both a challenge and also a tool. I think it really puts pressure on us, but it also creates a very good communication tool with the public. And the benefits of the roadmap would be that common vision that we have, being more efficient and cost effective, and extending the planning horizon of the various documents, including the Global Air Navigation Plan. Here are a few of the required prerequisites to progress the ICNSS report. Once again, for those of you who have very good eyesight and who are very quick at reading, you'll have time to digest all this. Otherwise, you can refer to it when the presentation will be distributed. The streamlined CNSS standardization framework, well, that was what I was mentioning, the new approach for the development of SARPs and detailed technical specifications, more performance-based to ensure interoperability, and having benefits of less frequent amendments for Annex 10. Having also there would be a bit less heavy, and we support the speedy implementation of new technology and also close coordination between SMOs to facilitate the timely delivery of all provisions. This is the vision that we had. We know that a large part of the industry is in line with this and requesting this. So conclusions, I mentioned the prerequisites, and following what I have said, I would say there are 6 major prerequisites on which we can build the future. The first one is the collaboration among the states, among the stakeholders and regulatory bodies. Collaboration is not just something for the future, it's something for now. And we know that collaboration is not easy, but there is more to gain than to lose. Globally, the entire community, with be it international stakeholder, can be winners. There are very few areas where we can say that anybody can win alone. Collaboration means being ready to make decisions, and we need that to happen. And there's a few areas where we need those decisions fast. They can go either way, but they need to be made. And our responsibility, the collective responsibility that we have, is to understand that these decisions are the key to the future, and that until they have been made collaboratively, we will not move forward. And we can make all the calls we want on the industry, the operators, until those collaborative decisions have been made, we're not moving forward. The agility in being capable of continuing operations during both planned and unplanned outages affecting GNSS. This is one of the key. We have addressed some of the issues here. I think there's a general vision of where we want to go. This is going to be one of the topics we address in the assembly of ICAO in next September and October. And I'm quite sure that there will be a lot of papers on GNSS interference. The third one is the promotion of the interoperable digital trust frameworks, and also encompassing, as I mentioned, all the logistical outside of aviation aspects that we have to look into. We have to move now. I think the theory is there, the digital tools are there, we have to move forward and collectively say that we're ready to move forward on this. The promotion, the addressing of challenges posed by drones, urban air mobility platforms, and other emerging technologies. Everybody is working on this, and I've seen a lot of presentations in this very conference about it. Developing roadmaps for CNSS evolution. Those are going to be fundamental. And lastly, streamlining the framework for CNSS standardization to foster innovation while maintaining interoperability. And I believe that if we manage to do all those 6 things together, then all the promises that are being presented today, all the brilliant young students we have seen with papers, ideas, they'll be able to move forward. If we don't make it on those prerequisites, this work risks being forever stalled or lost. So it's all in our hands. I'm looking forward to see all of us working together. I'm looking forward to see many of you come to the assembly and reaffirm the solemn promise of aviation to work internationally, to work collaboratively with only safety, security, sustainability at heart. And if we do this together, well, we have a bright future for the integration of CNSS. Thank you very much.
So, Pascal, I think ICNS Conference has really very long-standing cooperation with ICAO, and thank you very much for coming to all the events. And as a token of appreciation, we have a small crystal for you, actually, just to thank you on that.
Thank you so much.
I will just take 1 minute. I mean, because ICAO is really a standards-making organization, I think also I will leave for a moment my ICNS hat. So I will take my EUROCONTROL hat. So also EUROCONTROL is a developing organization of standards. So we are really looking forward to support with the work that ICAO is doing, the other standards development organizations are doing to really make the standards needed for CNS available, and not only for CNS. So thank you for that. I think you also have done a very good introduction to the next plenary session. So I don't have to say more things. So I will ask Paco Salabert, the policy officers from the CNS Commission, to come and talk about the cybersecurity, the CNS cybersecurity and PNT resilience.
Thank you. Thank you, Nikos. Good morning, everybody, and thank you to the organization to give me the opportunity to chair this session that I think is going to be one of the most interesting sessions of the conference. So the subject, cybersecurity and PNT and resilience, is on the spotlight. Everybody's attention about jamming and spoofing, cyber attacks, political level, technical level, operational, even the public. There are even some passengers in the Baltic area that are starting to be concerned about jamming and spoofing. So we are in the spotlight, and we have 4 excellent speakers. So all ingredients for an excellent session. I'm just going to introduce from my side to complement the work that ICAO has presented about the work that they are doing on addressing the subject of security and GNSS jamming and spoofing. So as he mentioned, I'm going to repeat, this is not a risk, it's a reality. It's the new normal. Jamming and spoofing is not a contingency. In some areas, it's the new normal. And I just want to highlight to you that one of the 2 elements I want to highlight, one is about the lifetimes. The lifetime of the spoofing industry is 6 weeks, and the lifetime in aviation is 7 years. So for me, that's the problem that we have to face, because in the cybersecurity, in the jamming and spoofing, the technology goes very fast. They introduce new ways to overcome barriers. And in aviation, because of our standardization process, certification process, we know let's say, takes a long time. So in general, ATM, there is always a resistance to change in institutions because of lack of investment, business case, certification. There is always a resistance. But I think this case of security is something that we cannot afford to wait. We need to react now. Safety is at risk. The continuity of operations is at risk. The geopolitical situation could become worse, and we need to be prepared. So I don't want to present a black situation, but this is as it is. We need to be prepared with actions to address these issues that we are facing now. There is another aspect that I want to highlight when we talk about integrated CNS. It's about using one sensor for many CNS applications. So GNSS is one of the perfect example of integrated CNS. We are using GNSS for navigation, for PBN. We are using GNSS for ADS-B surveillance. We are using GNSS for CPDLC, data link. We are using GNSS in many aircraft systems for timing, but GNSS standards were not designed to be protected in electronic warfare that is what we're suffering today. And we have had an over-reliance on GNSS, that's my view. So now we need to see how we can take the lesson to avoid the common model failures, because the common model failures is the tricky part of the integrated CNS. When we are facing these issues, we don't want that the systems that are relying on GNSS affecting the three services in CNS. Even the calibration of the conventional navates, ILS, DME, are based on GNSS. So the backup that we are having to protect against is reliant on GNSS in a way. So the message is that integrated CNS is fine, but we need to avoid common model failures in the time to go, in the architectures for the future, for the ground systems, for the aircraft systems. But the problem is that we don't have time to react. GNSS jamming is there, security, cybersecurity threats are there. We will implement digital certificates in SWIM. We have this trust framework that ICAO has presented, but it will take time and we need to react fast. So for me, this is the big challenge that we have, the lifetime pause. The problem is now, and we need to speed up. We are urging all the industry organizations to react fast because this is a subject that is putting at risk safety, security, and continuity of operations. So I don't go further on this. I will leave more time for our speakers that are going to develop their views and addressing this issue. We have Krishna from the Embry-Riddle Aeronautical University that will present first the methodologies, how to manage security. Then we have Per from the SESAR Deployment Manager that is in charge of SWIM and cybersecurity, and is going to present on the digital certificate activities that we are doing in Europe. We have Mathieu from Airbus that is going to present what Airbus is doing to mitigate GNSS interference. And our last speaker is George Pereira from EUROCONTROL on the civil military, giving the civil military perspective on how to cooperate better between the civil and military in addressing the cybersecurity and the GNSS interference risk. So the first speaker, Krishna, you have the floor. Thank you.
Well, can you hear me fine? Good morning. So thank you again to all the organizers, including Braino sitting in the back, to get me here. I was not sure till the last minute whether I can make it, so I did. So let me talk about briefly a bigger picture in this particular area. This kind of general outline, I have 5 slides and I will go through these bullet points right here. First of all, taking a step back and looking at what are the cybersecurity concerns in aviation, specifically in the context of CNS ATM, looking at current approaches that assess and mitigate the risks, what are their shortcomings or their weaknesses at this point, and looking at the future a little bit. So if you look at today, you have in this case the attack type, which is either physical or cyber, or the attacked asset, which is the physical and cyber. So most of the aviation security has been focused on what is a physical attack and what is a physical asset that's being attacked. And that's where the top left quadrant, you can see that. The current focus is on the cybersecurity, which means you're focusing on what cyber attack is targeting what cyber asset. So that is where the cybersecurity comes in. Now we're going into the GNSS spoofing and jamming context. That is where the cyber attack actually targets a physical asset. So in this case, let's say a pilot is looking at a flight navigation, and then there's a cyber attack that targets that pilot to think it's actually in a different position. That becomes a cyber physical attack. And then you have electronic warfare that Paco mentioned, which is a physical attack on the cyber, which is the data. So that is the type of attacks that are coming up. Recently, unfortunately, there have been a lot of manifestations and examples that have come up, not just the GNS spoofing, but also perceptions that maybe this is a spoofed message on TCAS, on ILS, on those kind of things are coming up. So CNS ATM in general is having the cyber physical security issues that need to be addressed. Now, that is where the new surface comes in. Physical security is no longer the focus, just that it has to be more holistic. This is where we come into the context of how do we assess the security risk for an aircraft, which is nothing but a cyber physical system flying across from point to point. That's the ultimate mission of aviation. So what you see here are the flight phases, right from the takeoff, from taxi to takeoff all the way to landing. And you'll see that there are multiple systems exchanging multiple types of data that you see there. And also the aircraft itself is a physical asset which has got a pilot on board who she or he are manning that aircraft. And then there is also safety related issues that this is the point of time where you're actually having a lot of pressure to maintain safety. So you see that the risk profile is dynamic. It's no longer a static value. So you can't assume the risk for this flight is just 1 point. There are multiple transition points that have to be addressed. So that is where you have to look at the acceptable risk and mitigate it if it is unacceptable. Now, let me take an example how cybersecurity risk for aircraft is assessed today. So in this case, hoping you can all see the slides in your screen, but here's an aircraft which is in flight, and it's interacting with both ground, space, and airborne assets. And what you see is there's a pilot inside who has electronic flight bag that they're using to support CNS services. So this is what the block diagram looks like. Today, the risk assessment requires you to identify what are the assets and then draw an architecture that connects all of them together. So you see that there is a whole ground station, airborne transponders, and satellite-based assets that are interacting with the aircraft, and the aircraft itself is a system of systems. So you see that there is the airborne transponder, there's a portable electronic flight bag that receives data, and then there's a multifunction display the pilot sees and operates with. So you see that the assets identified there, the MFT and the electronic flight bag, and so then you can identify after that a data flow diagram. This is again the standard practice today, that you go from the architecture to a data flow diagram that shows you the different trust boundaries that are there. From there, you identify and document the threats that are applicable to you for your assets. And so in this case, for example, there are two of them. One is a multifunction display, the other one is electronic flight bag, and how they're impacted by different attacks. And then you map it onto a standard risk assessment matrix that you see here with the two example threats and see if they're acceptable or unacceptable. If they're bordering on unacceptable, you kind of mitigate it with some measures that can bring down the likelihood or the consequence of the attack. That is what the current approach is. What is missing is that there is a big gap in terms of how is the aircraft dependent on CNS ATM. That is not really addressed, it's trusted mostly. And so that's a big gap. And also cyber physical threat is not the focus, cybersecurity is the focus. So that's where the gaps exist. And so these are the examples where, for example, the airborne transponders, GNSS, the ground station spoofing, and the pilots are not taken into account in this context. So let me take a final slide. This is the ADSP. You know what ADSP is. It's an open exchange of data. And here you have both airborne use by the pilot or the autopilot, and then the ground-based use by the air traffic controllers. However, as you know, ADSP doesn't come with security in design. So that means there are spoofing, flight privacy, and other types of threats. So in this case, you have to consider holistic picture, which means you have to look at not just integrity, authenticity, availability, and flight privacy, but also the airspace security and cyber physical resilience. These are things that are missing today. And as you see on the right-hand side, there's a ground-based application and there's airborne applications. What is a big gap there is the airborne applications of ADSP. For example, it can be TCAS and other things, but ADSP is pretty much open to research that needs to be done to address those threats. So that's essentially where I wanted to leave it at, so that others can chime in on their thoughts. But that's kind of the big picture for this particular area. Thank you.
Yeah, thank you for having this opportunity to speak about authentication in ATM in the ICNS. Of course, what we have heard so far, I will actually repeat some of it, but that also emphasizes that we also have started to agree on the issues that we are facing. So that is hugely important. That is a vital step for us to be able to move forward. So my presentation here, well, I'll just have to use a few minutes on the problem and the objective. Also going back to some of the presentations that has been here before, because I think we say in many cases the same. Then I have two examples, and here I will dig a lot more into the technical details on how to apply cryptographic technologies into the area where you heard about GNSS. A specific of GNSS is of course the SBAS. And here I will show how the application of geographic technologies can actually improve the safety and security for this service. And the second one is about, it's very similar. It's about the surveillance and the exchange of radar information. So the problem and the situation, I think we agree on this. Communication is not secured on the application. We heavily rely on closed networks and perimeter defenses like firewalls, etc. But that also contradicts what we want to achieve in aviation, because we don't want to keep information closed or guarded in by these closed networks. We want to set information free, and that is actually what we see in the European regulation, the Common Project 1. This is one of the primary goals with what we intend to do, is to make the information within aviation available to all. And we don't do that by keeping it behind closed doors, as I mentioned here, the closed networks and the perimeter defenses. We also heard about my Christmas telling about the air-ground issues, and in particular ADSB. It is not secure by design. And this is really, really important, secure by design. We need to design our communication to be secure by design. Security is not like salt and pepper you can add on your dinner. It's something that it has to think into the standards themselves. It's hugely important. And even more important, we are moving aviation into a phase of digitalization. Everything we work with will be digitized. So there's a huge change in how we do things. Doing that also requires us to be able to communicate in a secure way. And we have to start applying these technologies that is out there, has been there for, I dare say, a couple of decades. They are proven, they are reliable, and we need to take them on board. So I mentioned the Common Project 1, and I think that's a really, really important statement in the Common Project 1. And this is to achieve the cybersecurity objectives appropriate for the service or services. So when dealing with cybersecurity, we are not supposed to invent the Eiffel Tower each time we need to do a little thing. No, we need to apply the technologies that will sufficiently secure the service. So it's not one size fits all by far. So the solution that we are looking into, especially when we look into the Common Project 1, but would also exemplify this when I go to the SPAS example. Identification and authentication is key. I also heard that from our previous speaker, that authentication is mentioned several times. We need to be able to authenticate the origin of the information that we deal with. That's hugely important. When that is achieved, then we can start also applying other cryptographic technologies. And I will show one here for the SPAS and the asterisk, that is the message authentication code. But combining the two, and this is the key, combining the two will secure both the integrity of the messages that we exchange, but also the authenticity of the messages. That combination is really strong. So going into the technical details. I'll just, oh, sorry. Yeah, we already heard that SPAS or GNSS is vulnerable to spoofing. It's also vulnerable to tampering, but we can actually do something about this. And this is what I'll show in the coming slides. So, but it is, as we rely more and more on these technologies, we certainly need to do something about it. So for SPAS, SPAS can be secured by actually relying on two different technologies that will support each other. So it will rely on the combination of the asymmetric key and asymmetric keys. The symmetric keys is that what you can see in the bottom of my illustration to the right. That is the Tesla one-way chain. I won't go so much into the detail on the Tesla, but if one of you should be curious about it, ask me afterwards. I'll be happy to answer that question. So that was a hint. Thank you. But it relies on this hierarchical four-layer model, where you have a trust anchor in the top. That is the identification of who you are. Then you have the issuing CA and a layer providing the keys that we're going to use for authenticating the messages. So in this illustration, what is important here is that for each of the SPAS messages, a message authentication key is calculated using one of these Tesla keys. I mentioned Tesla again. For every fifth of the messages, the message authentication keys, a hash is calculated by the and this is by the ground station. A hash is calculated and is digitally signed with the private key. I'll just go one back. The private key, you will see that on level 3 here, or what is referred to as level 2. So this is where the private key comes from. This is then distributed. Now, for the receiver of this, the receiver can actually validate this by using the public key. And by using the trust chain that I showed you before, then you know that this messages has not been tampered with, and they are originate from the right source because of the trust chain that was also implemented. So combining the two, the message authentication code and the signing with the key ensures that it is the integrity is kept, and also the authentication of the originator is guaranteed. So this is an example of how to apply this into an SPAS environment. A little different. Maybe the most important thing here is just to look at what we have on the right side. That on the bottom we have the Tesla hash points or the confirmation of the message authentication codes. We have the validation on the hash that is then digitally signed that we can then use to authenticate the originator. So this is a practical example. This will work, and it will really secure the SPAS implementation. About asterisks, in Europe, surveillance data is widely exchanged by using the asterisk protocol. But the problem with asterisks is, as with ADSB, as we had before, it's not secure by design. There has been some attempts to actually modify the asterisk protocol by including a new specification and the CAT 000, and applying again here standardized crypto technologies. Everything is standard. It's been here for years and years and years. It's not just not been applied into aviation. So there's been made a prototype actually here, and what you can see in this example is that actually the secure part of the exchange of the asterisk messages or the radar messages is added into the flow of information. So in this case, you can see that, well, we don't have to change the sender or the radar. We don't have to do this. We put in an extra layer securing the communication. And same on the receiver side, we add an additional layer here. What I'm going to say with this one, because it really relies on the same technologies as I explained before for SPAS, is this. It's only a prototype. And this is not a new thing. So my point here is that we also need to look at how we take these technologies, these new standards, into operational use. It's not enough just talking about them, producing paper. We need to actually do things to actually change the way we exchange information. That was the last one. Thank you.
Good morning. So jamming and spoofing, the perspective of an aircraft manufacturer. So my name is Mathieu Yallet. So I work in Airbus, and since last year, I'm leading a multifunctional team. So a small group of people, a task force, only focusing on GNSS jamming and spoofing to coordinate the work inside Airbus, but also outside. That's why I'm here today. So we've been knowing jamming for years, let's say a decade in Airbus, but 5 years ago, I would say, we started to have some reports of time spoofing, and then things accelerated, and we all talked about it, some very simple spoofing at the beginning, and now an explosion of all the spoofing events, especially since 2 years. At the bottom right part of my picture, you can see an Airbus dashboard. So this is a recording tool not based on ADSB compared to other tools. It is on recorded parameters on board aircraft. It is a delay of 24 hours, but it's a tool for us to do troubleshooting. And also we make it available to our customers who are connected. Apparently, it's very useful for the dispatcher and to prepare the flights. So seen from the aircraft, let's have a clarification. So these are clusters of events, but there are two clusters. The first one, I would call them the dump systems. Okay, the first one on the top is the terrain system. And on the other one, the more robust system, the navigation chain. So surveillance system, the terrain first, takes the GPS as it is. So we have a huge number of false alerts on the terrain systems. And unfortunately, it is combined also with traffic and weather loss, not false alert, but loss on some programs because the surveillance today is integrated in the same box. The other family is that we have problems on the navigation chain, but it's more a concern of loss. So we have this phenomenon of latch. The GPS receiver are blocked. So we lose the position, but we lose also the time, which is a very bad, it's very bad for RNP, but also for data link applications, which are no longer serviceable. So we have a lot of operational burden on the oceanic area. You could look at the bottom, 45 functions are linked to the GPS on board Airbus aircraft today. That's huge. Some figures. So you see at the top, the Airbus life in 2024, my life was 800 occurrences. So an occurrences, it is one report from one airline investigated by our team and shared with the EASA. Sometimes in one occurrence, you can have 65, I remember that airline, 65 TOS alert, super use TOS alert in one event. At the bottom, you can see this amazing number, 15,000 events for a major airline in the Middle East. So it was Airbus and Boeing fleet taking together, but 34% of their total flights affected. So beyond the operational burden, here my highlight is to come back on the terrain system. Today, we have a risk of crew complacency with these cockpit alerts because there are a lot of alerting. So our action so far, so 3 axes, we have worked a lot with our customers, we have worked a lot with EASA, and we have worked a lot with you, the aviation community. With the customers, we did a lot of regular webinar, regional operator forums, flight safety conference, and especially we updated all our pilots' procedures. So the supplementary FCOM procedures for our pilots today. All the 45 functions are theoretically analyzed with EASA. So for an aeronews, GPS, what are all the consequences? And we have a continuous monitoring with EASA. And then aviation community, we are here today, a lot of connection with ICAO, standardization, and the rest of the industry. With the rest of the industry, especially Boeing, we worked on a roadmap because roadmap are important. I heard it before. So we have a roadmap. It was presented in ICAO. This is the ICCAA approach. It was also a means for me to convince my management that we have a lot of things to do and that it is an important topic. So there are 3 folds, 3 columns. Rapidly, the first column on the left is we have to be ready by 2 years. Some solutions operationally, in the field by 2 years. The medium term, I would say it is by 2028 because the aviation industry is long, and the longer term is more 2030. So the left column, I told you, we updated all the procedures, but we have to analyze all the reporting, the new reporting, and to update our procedures, to work closely with the continuous airworthiness. And one important point also, our procedures are based regarding where are the spoofing area. But actually the flight crew don't know. You know approximately where they are. So we have a lot of initiatives today to propose something on the flight deck to the flight crews. So many initiatives, but also on the ground. And so there is a call to the community, I think, to have such tool to know where are the spoofing areas. The last, as I told you, we need to urgently update the surveillance systems, especially the terrain awareness system. One point on the data link, the issue is on the clock, this timing spoofing. Today, we ask the flight crew to go in internal clock, so no longer synchronized with the GPS, and so the data link is not serviceable. And to be honest, we don't have any short-term solution for this problem. Medium term, we have to update the navigation chain. I won't go into the details, but let's say we have the antennas, the MMR receiver, the GPS receiver, the inertial systems, the FMS. We are working closely with our suppliers. We have a lot of trade-offs, I think, to come because we are system architect, and I don't think we will upgrade all the systems I mentioned before just to protect our customers of the cost of all these investments. So we have to smartly decide where we need to do some modification for the medium term to retrofit aircraft and for the new aircraft. Longer term is more for the new aircraft, for the line fit. So for sure, we want to propose some improvement to the GNSS thanks to the standardization, to introduce authentication, to introduce maybe multi-constellation, but it will last long, maybe after 2030. As I told you, the community, we have to work on a time reference, a robust time reference, because today it's really a pain and we don't see a very short-term solution. And then, as told before, complementary PNT, we really need to work with the existing Navate PBN operation without GNSS, taking credit of the DME.
So this is the industrial roadmap today. So in conclusion, we are very active on it. My year 2024 was really, really busy, but I think the 2025 will be the same. One thing to retain of my presentation, I think it was said before, but in-service feedback is essential for us to determine the good systems evolution and also to have the good procedures. And today what we are seeing is that we have less and less reporting by our airlines because they are fed up with this issue, but I think we have to repeat. Please keep on reporting. Thank you for your attention.
Good morning, everybody. George Pereira, head of CNS security unit within Civil Military Division EUROCONTROL. We are all aware of the present defense and security situation, and this is maybe a good justification to pay attention to the challenges that we have in terms of security. And that I would join that to the fact that we are facing air traffic congestion. In Europe, we had yesterday more than 30,000 flights, and each summer is a nightmare. It means if you look to the traffic forecast for the medium term, we may approach in 2030 50,000 flights a day. And I can tell you the existing aviation infrastructure is not suitable for those levels of traffic. And for that reason, we are in the process of defining what will be the future aviation infrastructure. In terms of CNS, we try to identify how to enhance the increased connectivity and automation. We try to get rid of over-provision, redundancies. We are somehow migrating the technology from the ground into the cockpit. We rely more and more on satellite signals. We have higher levels of integration between the different systems. And we try to move away from equipment-based approaches to performance-based approaches. And all this evolution increases drastically the vulnerabilities of the systems to disruption and to cyber attacks and so on. And this is the reason why we speak so much about resilience. I've been invited to come here today to speak about resilience, and I believe it's a buzzword, yes, but there is a justification for this buzzword to be in front of us these days. We need all to have common understanding of what does it mean, resilience. It is not the same as safety, it's not the same as security, although there are some elements of it. But resilience, it's the ability of the systems to, let's say, react to disruption and then to maintain the proper level of performance. And this is applicable not only when we have accidents, incidents, but also in nominal circumstances. And this means that the processes that we have in aviation to deal with safety and security, which are well defined in the ICO annexes 17 and 19, they are not completely covering, I would say, or applicable when we discuss resilience. So we have another problem, which is coming from the ICO Annex 10. It's the technology life cycle of aviation. The life cycle of aviation is, well, it is there for some justified reasons, because we need to avoid common points of failure. We need redundancies, and we have everything is highly standardized. For each technology, we need to develop the SARPs, the MOPs, the MASPs, and so on. But each time we introduce some new technology, then we have to retrofit thousands of aircraft. And it's a nightmare. And for that reason, if you look to the aviation infrastructure that has been defined by the ICAO Annex 10 that is in operation today, I have to say it's rather obsolete. And this is, the problem is that then the equipment are not equipped with the proper filters. You don't have interference mitigation possibilities in place. And this is the reason why we are facing the problems that we are facing today. So I have here 3 examples, and I give you a little bit a flavor of on how the military see these problems. And these are only three examples. About the GNSS availability that we are discussing these days a lot. At the moment, we have a regulated function in Europe dealing with this, which is the function conducted by the EUROCONTROL as network manager, where my colleagues, they perform the so-called monitoring of the performance of the infrastructure. And this includes a lot of awareness, available information describing the situation. So for the short term, what we can do is raise awareness, define some procedures, and take radio regulatory measures, or measures next to the radio regulators. And we have done that. So we have an ICAO state letter. We have even triggered the attention recently of the United Nations to the problem, because on this problem, who is responsible to solve GNSS disruptions? If you have an interference, then you have to speak with the spectrum regulators, and they have to take action on that. Is this working? I don't think so. But okay, we follow the process. This is the normal process. Now, the solutions will come for the longer term. Dual constellation multi-frequency, a new generation of GNSS receivers, use of authentication to mitigate spoofing. Spoofing is the new jamming, as we used to call it. In the eastern flank of Europe today, 50% of the flights, they suffer a sort of GNSS disruption these days. And as Paco mentioned, it impacts 16 aircraft systems that range from terrain awareness to many other important systems, including the clocks that synchronize data link, ADSB, and so on and so on. Now, the military are a bit lucky because they have some robust systems in place. We had some trials in Spain that demonstrated that the restricted signals of GPS, PPS, precise positioning service, are more robust than the SPS. And it was already a military policy, including from NATO, to rely a lot on terrestrial navaids, such as TACAN, for the bearing and ranging services. Another domain that is important, and it's also covered by the network functions that I mentioned before, is to ensure that the surveillance infrastructure is not suffering from congestion. And for that purpose, we need to avoid that the 1030, 1090 megahertz bands are not, let's say, impacted by over-interrogation and transponder availability and so on. And the military, there we have a very particular interest, because when the flights take place, we know they need to be detected by the surveillance system for separation and identification purposes, but the military need to conceal the information because those flights may be sensitive. And for that purpose, it is accepted that the military may revert to mode 3 alpha, rotate the 24-bit addresses, and then the military are operating radars that are mobile. And when the radars are those radars are operated, it is important that they rely on the interrogator codes that are coordinated with the civil side, and NATO is coordinating a number of codes on for that purpose. we are all aware of the problems that we face when 5G telecommunications was deployed, because it impacts the radio altimeters. So the main problems were noticed in the US, but this is another domain that explains what happens when you operate obsolete equipment, not equipped with the proper filters and so on. There were studies conducted at the level of the CEPT, and there is technical work ongoing at the level of EUROCONTROL RTCA, and we manage on our side to ensure that some specific military information is used in those studies. And we also aware that significant technical work was done by the US Air Force, US DoD in US, and we were in contact with them as well. So it means in all these domains, the military are active, and we can coordinate with military and take advantage of some good synergies. And this is what I wanted to describe in more detail in the next slide. The obvious approach for me is to get in touch with NATO, because the NATO, Article 3 of the Washington Treaty, identifies resilience as a main topic of the responsibility of the member states, yes, but for that purpose, NATO created a resilience committee, which is in close contact with the NATO Aviation Committee, and they have defined, they have a subgroup for transport, air transport, and they have identified 7 baseline requirements for resilience, and those include the resilience of the civil communication networks and the resilience of the civil transport network. So it means the resilience of the civil is also a requirement for the military. All right. So for the infrastructure, the CNS infrastructure, the North Atlantic Council of NATO approved an aeronautical CNS strategy, and I can tell you it's security centric. So we have a tendency in civil aviation to be safety centric. In the military, we have a tendency to be security centric. And if you see the elements of resilience in this CNS strategy, they mention the use of TACAN as a fundamental aspect, and the reliance on terrestrial nav aids as a very important element. Of course, taking advantage of satellite signals were required, but not as sole means for sure. And they propose a total system approach for aviation, where if you have an holistic approach, then you take into account let's say, the implications between the different components. I am the co-chairman of the NATO EUROCONTROL Security Coordination Group, so which is a platform that we have in place to coordinate security-related aspects. And the NATO, the NCIA agency in the Netherlands, they have a program to address the situations where we interconnect civil and military networks, and I believe this could be important to take into account. And of course, on top of all this, we are also in contact with the national military authorities, and they have lots of practices that could be relevant if we synergize. I list now a number of domains where civil-military coordination could be beneficial. We have a tendency in aviation to, let's say, not consider to avoid security when it's only considered as a cost and not a clear benefit. So therefore, the business cases in that respect are normally negative. But now I think it's time that we start paying attention. So it's normal practice in the military environment to introduce encryption when we need to address confidentiality. When we speak about spoofing, it's a normal practice to introduce authentication, and integrity is also a normal aspect considered whenever we develop military systems. Anti-jamming and interference mitigation are normal features of military systems. I mentioned frequency hopping. I know that in most cases, these things are not, or this approach are not suitable when we are in the civil aviation context, but if we face threats, then there is something we need to do. There is a significant focus on electromagnetic spectrum because I believe in civil aviation, we have not done sufficient research on the spectrum compatibility problems associated with aviation, considering, in my opinion, spectrum the most valuable asset of aviation, and we are not addressing it at the right level, I believe. Although there are some security, let's say, services in place, I underline directory services for ground communications, IP networks, public infrastructure, and so on. The way we share information between the civil and military, we need to go back to that and address the challenges related with that. The data links that are the air ground data links that we have in operation, in my opinion, the ATN protocols need to be improved, and the communication management unit consistency is also an area that should be improved for the, let's say, the future deployment initiatives. GNSS mitigation I mentioned already, the military using their own restricted signals. Backup policies we've mentioned here, CPNT. We believe TACAN it must be part of it as well to improve the DME coverage and also, let's say, to take advantage of the fact that it's a more robust system. The holistic approach that I mentioned before, so combination of sensors when possible. This is a normal practice in the military. Coordination regarding surveillance to ensure that the information is concealed where it's needed, but not hampering the infrastructure performance. The use of primary surveillance to track non-cooperative targets, it's also an area that is difficult. And here I'm not speaking about the long-range 3D radars used for air defense, but some military primary surveillance radars could be more shared, or surveillance data more shared with the civil. And one more aspect I would like to mention is the dual use. So we are in a situation where we need a common infrastructure to be usable to support military mobility. Including when military aircraft are not equipped. So we need arrangements to ensure that the military can fly in European airspace supported by common infrastructure, because the segregation and sanctuaries is not a suitable solution for the future. So if that dual use infrastructure is supposed to be deployed, then it must be resilient, robust, and secure to the appropriate level. That's it from my side. Thank you.
Thank you, George, and thank you for the 4 speakers. I think we have 12 minutes for question and answers. But before we start, I just want to add a piece of information about the work that EASA is doing on this subject. Florian referred to the part IS on security. On the GNSS, EASA has published a safety information bulletin. I just want to let you know that they are organizing a workshop in Cologne in May with IATA. So if you want to follow up the discussion, there is this event in May, but let's start having the discussion. So the floor is open for questions to the 4 speakers. Thank you.
So I'm glad to hear some information about SERPAs, phased array antennas on aircraft to help mitigate GNSS interference and spoofing. In the US, the SERPA requirements are being moved from ITAR to export control this September. So my question is there a movement within the EU to take some of those restrictions within countries and move those to export control, which would allow easier integration of those types of capabilities to help mitigate interference, jamming, spoofing, and so on?
So I know that EUROCAE has started to standardize these adaptive antennas in one of the working group 62, but maybe Airbus wants to develop on that.
Yes, what I can add is that, so we know about the ITAR lift in September. I think it was a good news. Now we are working with our US suppliers that will propose us this kind of CRPA, but also more adaptive antenna, I think, which are out of this restriction. So to be honest, we are in prototyping phase. And definitely we don't know where we are going with this device, but we think definitely that's a really good mitigation.
Yeah. There are two European companies that are publicly selling, Turkey and Lithuania, very advanced SERPAs, 16 element devices. And to my knowledge, they're still within their own country ITAR restrictions. So that, yes, it's a very political slippery slope, but you know, if Europe was to go forward and move from in-country ITAR to a more unified export control restrictions, it certainly would make the integration and the fielding of those types of systems much more easier and more rapid to be deployed. So I guess that would be a suggestion for some of the within the European community to look at that and try to move those restrictions out of in-country ITAR to a more global EU export control restrictions.
Thank you for the intervention and the proposal. Next question.
Yeah, so this is Alex Arba from Honeywell. I will repeat to some extent what I said, I think, day before yesterday in this plenary forum. So I will ask a question for data link because that's what I'm doing, but I think generally it may be applicable to other insecure technologies that we use today. So I think, George, you were talking about the civil-military synergy. And what we are facing is that we, for example, in data link, we know that there are vulnerabilities which could be exploited in many different ways. And we know that the solution could be IPS, in our case, Internet Protocol Suite. But we also know that it's difficult to justify the business case to accelerate the deployment. Do you think that the path through military synergy could help us accelerate deployment of the technology that we know are needed, but we can't justify the investment just from the civil aviation itself? So do you think that if we could find more synergy with military aerospace users, it could help us accelerate development and deployment of these technologies?
Short answer, yes.
Then I will ask how, because we tried different ways how to approach NATO, and we were in the NATO advisory groups, like presenting, this is IPS, this is how it could be used by military, and everybody always says, yes, that's nice, but what next?
Yeah, well, maybe this is wishful thinking, you know. My wish is that this should be possible, but I know that there are trade-offs. So we need to go as far as possible. But for me, it's not. There is a cultural problem there as well. Sometimes you have a tendency to say that certain things are sensitive when they are not. You know, all the information we are sharing today, flight plan information, we share radar data between the civil and military. It's a normal practice. So we have to differentiate what is really sensitive and what it is not. And then at the end of the day, it's just a trade-off and a compromise, knowing that to justify investments on more robust technologies, then you know, you need to accept that security is part of the process, because so far we define our solutions on the basis of safety considerations. And we believe that we need a process in aviation where when we define a new system or new technology, we introduce a new technology, it needs to meet safety requirements, it needs also to meet security requirements and resilience requirements. And this is, sorry to say, we have not been doing this in the past, you know, because we have, you know, I was asking some colleagues, but why do we have interference on radio altimeters? Are the filters not good? And they told me there are no filters, you know, how is that possible? So, you know, we need a new generation of aviation infrastructure and systems that are not only safe but also secure.
Thank you, George. Next question.
Yes, hi. So thank you. Mario Wertmann from University of Stuttgart here. Thank you for the panelists. Very interesting insights from like different perspectives. I really like that. What I was thinking of is all of you wanted to do like more collaboration, more data gathering. Airbus showed a interesting statistic on that. So I think we need to process a lot of data, and we want to like have a faster implementation of existing IT technologies to secure all that. I think one part is that the certification process is quite extensive. It's quite manual all the time. So you need to do a lot of work. You need to do the work over and over again. So do you think that automation could help there? And what does the different parties like the universities and the standard organizations need to do in the future to like, make that process faster and help us bring that technology to life?
Maybe I can give some insight into what's happening, especially in the swim domain, because here we actually heavily rely on already available IT technologies, and therefore we also have the sort of the agility to change the standards, like we don't usually see within aviation. So you have a really good point there that we need to be much more agile. I just heard Parker, you said that the turnover or the time turnover for cybersecurity or in the malicious for the malicious actors is a week or a few weeks, 6 weeks, compared to our 7 years. So clearly that gap needs to be closed, but we also need then to rely on these standard IT technologies that we use that of course comes from the universities around the world. When we're talking about a topic like PKI, it's been there, I dare say, at least 2 decades, even more. It's not a new thing. We are surrounded by these digital certificates all over. Our phones are full of them. They are being automatically renewed every day. So there are so many things that we can bring into aviation that will significantly improve security. So I think you have a really good point that we need to also look into what has been automized in the sort of the civil world, because it can actually provide benefits to aviation as well. So I would very much like also universities to start looking into the aviation part and looking into the special issues that we are struggling with, because we have these very high safety standards. But we can't really just only look at the safety standards. The flip coin here is the security, and security becomes more and more serious for us as we digitize more and more of our systems.
Nikos, I think we have time for a last question. Good. So is there any question from the audience for our speakers? If not, I have a question for Mathieu from Airbus, because I think that one of the issues that we have discussed on integrated CNS, and I highlighted, is this, the dependency and the common model failures that you mentioned. There are like 45 functions using GPS position or time, or both. And what is your views about how to address this issue over time in the short term, long term, and medium term? You mentioned, can you elaborate on this? What is the process? Because I think also in Boeing will be similar, in Embraer will be similar. So is there any, let's say, activity at industrial level to address this issue for the aircraft manufacturers, to identify which boxes of functions are the most critical, or TICAs or warning alert systems, so that you need a short fix, and how this will evolve over time? If you can elaborate on that. Thank you.
So very short term, I will be clear. So on surveillance systems, we try to make them clever, but it will be rapid software update. So once that's said, the short term, you have to understand that this is reset. So we have, sorry, a switch on, switch off. Today, the procedures are built like this, and because we won't change the aircraft in 6 months, in 2 years. It will be difficult. So today our procedures are customized with before the zone or after the zone, please flight crew consider to have some switch off. So it's not very innovative, but it works. This is the big gun. No? So midterm, I told you about all the systems. I don't know for all manufacturers, but I suppose in Boeing that's the same. We have this chance to have this navigation chain, and we have to say that the inertial system is really the core system, which is independent. The accuracy of the inertial system are very good, and rapidly the inertial system is able to discard everything that goes wrong, especially a GPS. So I think the future of inertial system will be key, and we want this inertial system to be like the brain of the navigation chain, and to be able to inform all of the system with a kind of spoofing detector message to inform all the rest of the systems. More long term, I don't have so much opinion. We have better specialists here today. What will be worked in the ICAO, what will be worked in the standardization, complementary PNT, or improve a GNSS. I don't know. We'll see the future.
So I think has been an interesting discussion. I think now, as I mentioned, the work will continue because the risk is there. I mentioned this meeting in ICAO, in IATA EASA workshop. There is the upcoming assembly in ICAO when there is going to be papers and discussion on the topic and different levels. So we will continue on this topic. Also on the cybersecurity, the digital certificate is another area of interest. So thank you, and I now pass the floor to Nikos.
Thank you very much, Paco. Thank you very much, Krishna, Per, Mathieu, and George. That was really very interesting, the discussions. And the theme of cybersecurity and PNT resilience has been raised every single day. So it is really appropriate that we cover that one. We don't have all the solutions, but that is something important that we do address that one. So maybe if we put back the slides. So what I would like to do is that maybe try to take an opportunity to, thank you. We'll find it, I'll go back maybe. Thank you very much. So I think I mentioned also in the beginning that there is also Brent Phillips, that is the co-chair of this event. And I really want actually to highlight and put Brent into the picture here. So that conference has been really a cooperation between Europe and the US for many years. We have been working very closely with Brent, so I just want to thank him also for what he has done for this conference. It was not possible for him to be here, so we'll see for the next time. So now I think it is time for a coffee. So there is also, but what I want you also to do is that there is exhibits outside. And I want to say a big thank you also to the sponsors, the financial sponsors of this event that make this conference also possible. So I want to start with the platinum NASA, with the gold Airbus, with the silver Frequentis, Aerion, Viasat, and Intra, the exhibitors Startical, Sanhilo, and Honeywell, and also the supporting sponsors ESSP and L3Harris. We have also EUROCONTROL as a media sponsor, so thank you all for your support to ICNS. Thank you.
Check test on the test. Check test 1, 2.
So please take your seats. I think we are about to start the second part of the morning plenary. So I think we had some 5 plenaries really addressing different technological aspects. CNS is really a technological component, but what is important actually that we bring these CNS technologies to use and to the actual operations. So this is really that we're very happy that our 6th panel of the plenary part is really addressing the human part. And we need to see what actually needs, what are the training needs for this in order to make sure that these new technologies will find the way and provide the solutions that we need. And for that, I want to invite Luna Babusi, who is from SDM and is the airspace management team leader and air traffic controller. So to help us and guide us through this panel. Thank you, Luna.
Thank you. Thank you, everybody. And welcome to the last plenary session of this ICNS conference. The last plenary session doesn't mean that this is the least important. As you have already noticed during the whole conference, all the panelists, all the speakers mentioned the human role and the importance of the impact of this new CNS evolution on the human role. So that's why we are going to address these topics with those who are going to use these new technologies, from the engineers, from the air traffic controllers, pilots, and also the managers who have to deal with the change management, with the strategic vision to prepare, to pave the way towards this implementation to take place and to be accepted and usable by all the human role. We will also we will try to turn the view of this conference towards these users who are going to give us their insights and their perspective on this impact, how it will be translated into new ATC procedures, new ad hoc training programs, how the operators will live in the transition phase before this new implementation will take place in a proper manner. So I'm honored to be here, and I give the floor to our 4 panelists that I'll go to introduce. The first one will be Konstantinos Simayakis. Konstantinos is a CNS expert and also a regulatory expert at IFACEA, that is the International Federation of Air Traffic Safety Electronics Associations. Then Elena Sjöström-Folk will follow. Elena is the president and the CEO of IFATCA, the International Federation of Air Traffic Controllers Association, and she's also an air traffic controller as well and a supervisor. Thanks, Elena, for being here. Then there will be Carlos Sequeira. Carlos is a Ryanair airline pilot, but Carlos is also a human factor expert and a psychologist, and is part of the expert team at SESAR Deployment Manager, also involved in the CPDLC implementation. Then we will close this section with Roberta Zimmerman from US. Roberta is a manager. She's a director of air data analytics and strategic vision at United Airlines. But Roberta is also a pilot, a flight instructor, and an air traffic controller. It's not by chance that she is a woman, no? So I leave the floor to Kostas. Kostas, thank you.
Thank you very much, Luna. Thanks a lot to organizers for the opportunity that they have given me. As Luna said, we will try to outline the impact of the new technologies on the human resources. Actually, according to the ATM Master Plan, the deployment of CNS disruptive technologies, including artificial intelligence, is expected to be of utmost importance. Equal importance will be also the involvement of human resources. And this is outlined very correctly, very thoroughly in the ATM master plan, where it is stressed that ATCO and ACEPS will be invited to develop new skills and expertise in order to be able to realize the artificial intelligence methodologies. From the technology perspective, service-oriented architecture, service hardware or software as a service, virtualization, and so on, is expected to be implemented in a very large scale. That's also brings on the famous threats, cybersecurity threats, and professionals like ACEPS will be invited to deploy, to develop new skills in order to be able to cope with these new challenges, which is how to tackle the cybersecurity threats. But also the digital European sky highlights the needs for a resilient and reliable infrastructure offering 24 hours, 365 days a year, reliable and continued operations. On the other hand, as it has been underlined several times today and the previous days as well, the GNSS network, where the whole SESAR project is based upon, is suffering from radio frequency interferences like jamming and spoofing. This is something very serious and has been taken into consideration by EASA very seriously. And as a result, EASA has issued the Safety Information Bulletin number 2022/02R3, which has a number of recommendations and actions that have to be taken by competent authorities, by NSPs, and by other stakeholders like air operators, even maintenance, aircraft maintenance personnel, etc., organizations. In this, there's a very long list of actions that have to be taken in order to, in an effort, in a framework to tackle the problem of jamming and spoofing in the GNSS. Particularly for the NSPs, the cybersecurity, the Safety Information Bulletin of EASA underlines the need of keeping the existing, the legacy CNS infrastructure, which will be used for conventional or performance-based navigation purposes whenever it will be required. In addition, the contingency plans, the existing contingency plans have to be also implemented, and even in particular cases. And another measure which is coming to my mind now is that the ATCOs have to be trained, having enriched their training curriculum with additional items like jamming and spoofing scenario in order to be aware for a potential event that they will face during their work. But all these make obligatory the existing of two systems that we will be working parallel. The previous system, the existing system, the legacy CNS, and the new one. From a human resource perspective, it will be needed a huge effort to be always adaptable to the procedures of the previous system and the new one. And this, of course, will require intensive training in order to make them able to switch whenever required from one system to the other. But it's not so simple because according to the regulation 373, this is a huge change in the functional system. Functional system, I remind that it is people equipment, and procedures. Now we have a change, a repeated change on the systems and procedures. This normally, according to Regulation 373, has to be subject to safety assessment and safety support assessment. This cannot be done, of course, in a real system, in a real operational system, in a real operational environment where we don't have the luxury to stop and make assessments, safety assessments, so on. In that case, the corresponding ANSPs must foresee what could happen, what will be the scenario, and have in place the appropriate procedures which will be invoked by the corresponding personnel, the corresponding professionals, in order to be implemented as appropriate. As a conclusion, I think that it's obvious that the staff competencies will be of utmost importance and will be paramount for ensuring operational efficiency without compromising safety. This has to do with the intensive training that these personnel have to take and refreshing training always in order to be able to do their job and switch from one system to the other whenever it's required. I think that this is the message that I want to send, that in the future system probably will bring many benefits, but also from the human perspective, needs a lot of effort in order to be the corresponding professionals to be competent, and of course needs always to be vigilant in order to be able to switch from one situation, from one status to the other. Thank you very much.
Thank you, Kostas. So let's leave the floor to Elena now. Thank you.
Hello, everybody. Can I start with asking 2 questions from you, just so I know what the situation is? How many of you have an engineering background?
CNS.
Thank you. How many of you are familiar with the federation that I'm representing, IFATCA? That's pretty good. Okay, good. Thank you. So I'm not an engineer. I'm just an air traffic controller from Sweden. But what I do have is 37 years of operational experience. And that's 37 years in operations, not in offices. So in various towers, control centers, through my career, I have been working with the equipment that you guys have provided us with, and I'm very grateful for that. We all love engineers, especially when the systems fail and we have somebody to call. So I was working on primary radar, giving guidance to military traffic, and you know how fast they fly, in the early 90s, together with my good friend Billy Josefsen up there. Throughout my career, I've also in parallel worked for flight safety through the Swedish Air Traffic Controllers Association, and since the last 8-10 years for IFATCA. And the long term is International Federation of Air Traffic Controllers Associations. So that is a federation of air traffic controllers association worldwide. So I'm standing here with 37 years of experience and also my 40,000 friends behind me, because we have around 40,000 air traffic controllers as members. So I'm very grateful that you invited me, and also that you're taking a couple of minutes to listen to what I have to say. So the last panel of this exquisite conference, and the first that deals with the human element. So that is actually my core message to all of you. In my view, at present, and as far as I can see, and I think as you can see, the human is still the core of the system. And the only way, in my view, to be able to reach the future, to optimize the future, to get down delays and be more efficient and more safe is through collaboration, like Pascal also said. We want to be involved, the end users, pilots, air traffic controllers, and also our good friends from IFATSEA, the technicians. If we can work together, we will achieve everything that we want. I'm quite sure of it. We need to have the end users involved in the actual manufacturing and development of the systems. And there are a couple of reasons for this. One is, of course, that the end users, as was also previously mentioned, can be seen as the experts of what is needed, although we don't have the engineer's mind, so we can't even imagine the things that you guys can invent for us, of course. But if we are involved from the beginning, we will maybe hopefully not have the risk of having systems that are put out and then we have to start inventing workarounds. Because if we're honest, that's what's happening. That's what's been happening since I started in air traffic control. And this is, of course, very difficult now when there is such a shortage of air traffic controllers worldwide. But there are ways to work around this. So that's my core message: collaboration, keep the human at the center. And I will close with a short remark on a question that I sometimes hear. Is it true that air traffic controllers are against new technique? No, it's not true. But the fact of the matter is that we are tested, selected, and trained to be skeptical, always, to question. Is this aircraft climbing with the rate of climb that I gave him? Are the winds on final still the same as they were 3 minutes ago, or do I need to adjust my vectoring now? Will the snow clearers be able to get off the runway before my landing? And if not, what do I do? We're always skeptical. We're always asking why and what if not, because we need to have a plan B, C, D, etc. So thank you very much for inviting the air traffic controllers to this fine forum. It's my first time here. I hope it's not my last time. Thank you.
Thank you, Elena. I leave the floor now to Carlos Sequeira from Ryanair.
So a very good morning to everyone. I'm afraid I'm not as good as my colleagues, so I have some notes that I took the liberty to write a few bullet points. So a very good morning to all of you, distinguished colleagues, esteemed panelists, and all aviation professionals that are here today with us. It is a privilege for me to be here today to discuss one of the most critical aspects of our industry's evolution, and that is our advancements in CNS technologies' impact on the human role in air traffic management. The introduction of AI-driven CNS systems, digital towers, trajectory-based operations, and automation demands more than just new technical competencies. It also requires a fundamental shift in mindset, also a reevaluation of professional identities, and a change in how we train and support future CNS professionals, air traffic controllers, and airline pilots. While much of our focus is on the capabilities of new technologies, I would like to shift our attention to a fundamental question. How do we ensure that amid automation and all this digitalization, we can keep the human at the center of our systems? So the future of ATM, in my opinion, is not human versus machine, but rather human working with a machine. For CNS evolution to be truly successful, we must design systems that support human operators, and we must assist those operators in adapting to change. How can we do this? By applying certain principles that we use in psychology behind change management. As a psychologist and aviation humans expert, as well as an airline pilot, I believe that understanding some of these principles of the psychology behind change management is paramount in ensuring that these transitions are not only efficient, but also sustainable from a human performance and safety perspective. One of the primary challenges in this transition is what we call psychological resistance to change. Aviation, as you all know, is highly structured and safety critical industry where new technologies can provoke concerns about job security, loss of control, and increased reliance on automation. Psychological factors such as status quo bias, cognitive dissonance, uncertainty avoidance can all hinder the acceptance of new CNS technologies and advancements. Therefore, proactive change management strategies must be embedded within both the system design and professional training, addressing these concerns through transparent communication and also structured transition programs. Furthermore, as you all know, the role of ATM professionals is shifting from direct system operators to strategic system managers. This requires a new set of competencies. As CNS systems become increasingly automated, professionals like us must develop systems thinking, data interpretation skills, and human AI collaboration capabilities. The transition also demands a higher degree of cognitive flexibility and psychological resilience, as professionals must learn to trust and verify AI-driven processes while maintaining decision-making authority. To facilitate this adaptation, training methodologies must also evolve. Traditional rote learning must give way to competency-based, evidence-driven approaches that all focus on problem-solving and scenario-based learning, also adaptability under automation. Additionally, resilience training should be integrated into ATM education, equipping professionals with the skills to manage cognitive overload, automation bias, and trust calibration in high-stakes environments such as the one that we operate. Beyond individual adaptation, organizational change management is also necessary and critical for the CNS evolution. ATM organizations must foster a culture of continuous learning, promote cross-disciplinary collaboration between engineers, controllers, and pilots, and also adapt to structured change leadership models. So, ladies and gentlemen, as we navigate this era of rapid CNS transformation, we must recognize that technological advancements alone does not guarantee operational success. Our success will not be measured by how advanced our technology becomes, but by how effectively we integrate the human expertise in these advancements, and we must keep the human in the loop. By applying psychological principles of change management, for example, also investing in resilience-based training and fostering a growth mindset, we can ensure that CNS evolution strengthens, not weakens, the human in the ATM. Aviation, as you all know, has always been about innovation, but its greatest strength, as said before by my colleagues, has always been the people behind it. So let us ensure that CNS evolution enhances the human performance rather than replacing it by prioritizing a human-centered approach to training, adaptation, and system design. So I invite all stakeholders, engineers, regulators, trainers, and operational professionals who are here today to embrace a human-centric vision for CNS evolution, ensuring that innovation and human performance grow together in a harmonized and sustainable way. Thank you.
Thank you, Carlos. Now, Roberta Zimmerman from United Airlines.
Thank you. Thank you for inviting me to be on the panel. This is very exciting, and workforce is very near and dear to my heart. So I have a very, very tiny sheet here to work off because it's just how I'm going to roll today. So Luna introduced me. I've been very fortunate to have a number of careers so far in my life. I've been a pilot, a corporate pilot. I've been an air traffic controller at maybe one of the busiest and complex airspaces in the world. I've been a systems engineer doing research and development, supporting the FAA, understanding end-to-end concepts and how integration works or sometimes doesn't work. And then during COVID, I decided to join an airline, which was very unstable, but I'm so happy I did. So a little bit about United, if we're not familiar, I'll give you some numbers, and I had to write these down. And it does change on a daily basis what United brings to the aviation community, because we are growing. So as of, I think, 2 days ago, the mainline, we are at 1,018 mainline aircraft, expect to be about 1,030 in the summertime. Last month, we had our busiest month ever on record for United. We were able to transport, on average, 508,000 passengers per day. We expect to see up to 600,000 over the summer, and I will put a disclaimer that it does not involve the recent changes economically. So who knows what's going to happen, but hopefully it'll be up to 600,000 this summer. On average, we operate between mainline and mainline express, 4,500 aircraft per day. And from the network operations centers, which is where I work, we do look at and protect our express partners. They are one of us. Because in the end, the customer doesn't know that they are really an express aircraft. All they see is United. We go to, again, this changes because just last week we introduced some new destinations to the Pacific, but we operate to about 350 destinations around the world. So we are a global airline. One unique thing, though, to think about when we talk about airlines is we are a business within someone else's business. We operate within ANSPs, which we have no control over, but we are trying to operate our business within theirs. And we talk about integration and modernization. It is one of the choking points that we have to deal with, especially as we see equipment outages, frequency outages that impacts us and our customers. To say that we work in a data-rich environment is probably an understatement. We track every data point we can possibly track. When we reintroduced a favorite waffle snack back onto our aircraft not too long ago, we saw an immediate increase in customer satisfaction. We know when main doors close, open, when pilots arrive, flight attendants, we know when you arrive at the gate. We track everything. And part of this is too, one of the departments that I operate and run at United is the newly formed ATC data analytics team. We have always, well, since about 2018, we've gotten ATC data from the FAA, but we just instituted business rules around it. We formed a new team around it, and we are mining the data. We have operational analysts now that support our ATC coordinators. And if anyone has seen like the Moneyball movie, that is the concept of this new team. Sports is not sports anymore because everything is data analytics. They run plays based on who can hit, what pitch should you pitch to this hitter? Where is he likely to hit it? What, NFL, what plays should we run? And that is the concept behind our new operational analyst. We are running models. We are looking at statistics. We are trying to figure out how to mitigate delays given certain constraints. So that is an evolution, and we're very excited to be part of that. So as I talk about where we're going, how we're growing, it is a challenge in the workforce to find the right people with the right skills. During COVID, a lot of airlines were decreasing their footprint. We were increasing it. We put one of the largest aircraft orders on history during COVID, but we also realized from a pilot's perspective that we didn't have enough. So we bought a flight school called Aviate, renamed it Aviate. We also have partnered with flight schools around the country to have a direct pipeline into United. They still meet the same criteria and regulations per the FAA, but it opens the doors for people that normally would not have that door open. We are trying to mine some of the best assets that never maybe thought that they could be a pilot or that they could be in aviation. We are trying to tap that unknown talent by creating this Aviate program. I think that is also a great baseline cornerstone of how we should look at other industries within aviation. There is a lot of untapped talent, but we need to open the door for some of those untapped talent. I think we didn't know what we were each going to say when we came up here, but I did want to say without integrating humans. Whatever we decide here, whatever is shown to work, if we don't integrate the humans very on in the process, it doesn't matter how good your technology is going to be. And that goes from the whole workforce, from pilots to controllers to ramp towers to fuelers, etc. We really need to integrate the humans into the process. And as I close, since I have the mic here, I think this panel is fantastic. If I had seen 3 female controllers early on in my career, it would have been incredible. And I think, especially in this time, representation matters. It shapes perceptions, promotes understanding, and ensures diverse voices are heard. So I want to challenge everyone in this room to have more diverse and representation on your teams. In the end, it makes the product better no matter what. So thanks. I'm going to hand it back over to Luna now. Thank you. Thank you. Thank you, everybody, for these great presentations and speeches. Now, before opening the floor to the audience for questions, as we have very much time, I will take the chance to pose a first round of questions to you, okay? And you can feel free to answer. I will ask you, Kostas, before. Okay. So I'll address maybe a more technical question for you, as you are an engineer. Recently, we are listening to this working program that is addressing the shift from the legacy systems, the current ones, to this open digital architecture, service-oriented architectures. And by being here and listening to the different presentation made by the panelists, I learned about these cyber security threats. And I imagine that the skills that you are going to look at for the future aviation experts will be evolving, will be different than the current one. So what do you see? What do you think about this impact on the engineers, on the technicians?
Yeah. Thank you very much for the question. I think that everybody understands that the impact of the working load and on the routine tasks will be huge. I think starting from the fact that first of all, they have to take the appropriate training in order to make it possible to tackle the imminent threat at the very beginning before causing any damage on the system, because such a damage will jeopardize safety as well. And that's the main task, the main goal is to protect the safety. But here is a very, very serious job that has to be done from the states up to the international organizations in order to make it feasible. So with the advent of the new technologies, everything will be in such in the appropriate route in order to be able to cope with this new threat. I mean that there is a lot of regulatory regulations around. First of all, the famous NIS2 regulation directive, which has to be implemented by all the European states. I don't know if you are aware, but some 23 states have not yet transposed the directive into their national legislation, and that has caused the Commission to send a notification for sanctions to that to 23 states. The other, once this is transposed, it has to be implemented. Implementation means that it has to be adopted by the air navigation service providers to be part of the security management system that, according to 373 regulation, has to have in place. They have to have in place. In addition, there is another regulation, 2023/203, which will be in it has to be in place from January 26. And this has a requirement, very strict requirement actually, for information security management system. All these have to be coordinated. I don't know who will coordinate them. In addition, a similar directive exists, like the NIS2, exists in the United States. I don't know if ICAO has, I don't know what's the plan in coordination with EASA and other European organizations to coordinate all this legislation to be in a kind of, in a harmonized way to be implemented so that to make it feasible to tackle the problem of the cybersecurity. Once they have been integrated, the appropriate training has to be given to the professionals. I remember now that in Article 9 of NIS2, there is a requirement for the computer incident reporting teams. This is a requirement that every state has to implement, staffing for any sector and subsectors, the appropriate taking the appropriate staff to staff these CERTS entities, computer incident reporting team. This is a very, very important task where I suppose that for the sector of ATM ANS, ACEP will staff this entity, and they have to take the appropriate training, the appropriate to update the appropriate skills in order to be able to cope with these new tasks. This is a very complicated task. Many organizations from the state up to different organizations have to be involved in order to make it feasible. Thank you very much.
Thank you, Kostas. Thank you. Now, Helena, a more general question about air traffic controllers. We heard in these days about this integrated CNS, integrated meaning also as an integrated airspace with all the users, so open to all the users without delay, enhancing the capacity and having the controllers able to, thanks to this CNS evolution, to decrease their workload and so to enhance the capacity. So this means that controllers will have to deal with different aircraft with different performances in just one airspace without segregation. So I'm talking about not only drones, but also space aircraft for tourism, as we saw this morning. What do you think about it? Is it realistic in the near, long, short term, or is it not?
Do you mean, is it realistic to have no delays? No. No, is the short answer. Unless we can ask the airlines to spread out their business all through the day and night, which they don't want to do. So no, I can't, in the short term, I can't really see that there is a possibility for no delays, but what we're working towards, of course, is to get the delays down. However, safety comes first. And right now, when we have such a shortage of air traffic controllers in the world, we are grateful for the technical systems that help us, but it's still not going to be enough because we're lacking so many controllers in so many places that for the foreseeable future, we will not be able to catch up. So I think the question of how shall we change training? Yes, I can see through my career span that the role of the air traffic controller has changed slightly, and therefore also the personalities in air traffic control have changed. So when I was young and started my training, my older colleagues then, they were more of craftsmen and a few women as well, because the air traffic control profession was more a creation of what air traffic controllers made there and then. The aircraft came, sorted out. Nowadays, of course, we have systems that help us, which makes it more of a role of a systems operator, and I think we will head towards that even more in the future. So when I see the new trainees coming into my center, they are more the personalities, if one can be a bit biased, of systems operators, which is necessary. And without that, we would not be able to cope with the increase in traffic that we have seen in the past 20 years. But regarding training, what is the most important thing is that we train, that we don't stop training. Like so many air navigation service providers felt that they were forced to do, for example, during the pandemic. But it's not only the pandemic. During my 37 years working for the Swedish air navigation service provider, training stopped 6 or 7 times due to various reasons. And the air traffic controllers community always said, don't do it, don't stop the training, you'll never be able to catch up. So that's, to me, the most important thing. Don't stop the training, don't stop the recruitment, just keep going. There will never be too many of us.
Thank you, Elena. Thank you. And maybe this training has also to be enhanced, because when we have to be trained on new technologies, so and on the current ones. So, for example, if the GNSS happens, if it happens that there is a spoofing or a jamming or an error or failure, we have to go back to the current procedures. And what is the impact on the capacity? It's a huge impact, and also on the workload. And we have to be trained on this. So, in the short term, it might increase a little bit the complexity, But if you already know what is coming, we can plan on how to prepare our personnel to react to this failures, degradations before the full CNS comes fully implemented.
May I?
Yes, please.
Yeah, for this reason, I said that permanent vigilance is required, of course, provided that the people are trained as appropriate in order to be able to cope with this, the new operational environment, whatever it will be in accordance with the circumstances. The training, of course, as Helena underlined, is very, very important for the professions, for first line professionals, and of course for pilots, because pilots also have to deal with this problem. The sudden change of if we guess the scenario that we are in the GNSS environment, suddenly air traffic controllers have decided that they have to change because of spoofing or jamming or whatever, the appropriate ground equipment will be activated at a time. This needs, as I said, very, very careful steps that have to be done under the strict execution of a robust procedures that must be in place by the NSPs. Otherwise, the efficiency, the operational efficiency will not be secured, it will be not be ensured, with not security is guaranteed, and of course, no one can say that the safety will not be compromised. This is something very difficult. I suppose that will find it, you and the newer generations will find it in front of you, and everyone has to take it very, very, very seriously into consideration. The capacity, the impact of capacity will be, of course, if these steps are not carefully done, the impact of capacity will be huge. And we said this morning and the previous days that the ICNS and the future CNS will be performance-based system, and this performance, which will try to keep in a very good level, ensuring capacity and efficiency operations, etc., will be suddenly destroyed if this step is not done in a very careful way. Thank you.
Thank you, Costas. Carlos, you want to intervene?
Yes, I just wanted to make a quick contribute a little bit for the discussion, because we might not come back to this topic. So on my presentation, I was actually talking about fostering a culture of training. And on the topic of training, I think one of the things that I wanted to say from what she said is, I think it's also important to move away from the regulatory training, the tick the box thing that most of the organizations do. And that's all very good and it's necessary, but perhaps, we can start thinking about training both ATCOs and pilots for different things, psychological resilience, a growth mindset, as I said, but also, for example, something that we speak in human factors called trust calibration. So what does that mean? That means the amount of trust that we as human beings are going to give, according to what we know and what we have been trained, onto the automation systems. And in a world where it's becoming both on the aircraft and on the ground, everything generated by AI, automation, it is important for us also to be trained on that. And as a human operator, for me, for example, what is most important is actually to know how the machine is working. So in terms of decision making, and I think that this is important, you probably know it better than I do, because you probably use that a lot as well in ATC, understanding for the future technologies, which is probably what you're going to bring in the future, partly automated, where the machine is actually taking the decisions, certain decisions that you make, with that traffic management, to understand how it works and what was the processes that the automation led to that decision. Because if we don't do that, then we will start distrusting the system. And I think that's probably moving beyond the regulatory training, but it's a bit more from the organization to start training us on how to collaborate with the AI and with the automation.
Oh, can I just jump in about the cyber? So it's interesting about the cyber jamming and spoofing. I saw on one of the slides, the Dallas event and the Denver event. And I was at United during both of those times. And United flies into known risk of jamming and spoofing. And we know that risk and we accept that risk. The difference between the domestic instances that we have seen is that we are not, that we don't expect that risk in the domestic US. And that's, we had very significant impacts for both of those events because we weren't willing to accept that risk in that environment. So that's something that we need to train. We do train on it now. I think the ANSPs though, are not quite there in training and accepting because it's still unclear kind of what happens when we see that risk unexpectedly.
Yeah. Thank you, Roberta. Just to make a provocative question before I open the floor to the audience. We already say that the human should be at the center. We are the end users and we should be taken into account. But then coming to the realistic situation, the ANSPs and the airlines cannot release us because we are assumed to be there in the operational room, in the cockpit, and do our job. if we leave the operational room, so there is a delay maybe on the customer. And so how, as you are a manager, Roberta, what is your suggestion to let the companies prevent this risk and be really part of it, but based on some physical and let's say financial benefits to convince them to be part of the project, not only with the engineers, but also with the operational experts?
It's a challenge, right? It's additional workforce that we need to be a part of. But if we don't invest in being part of the solution, then that's on us. Then we can't complain at the end when we're not happy with the solution. And I think that's been our stance within the air traffic strategy group is if you're not present, then you don't get a voice. And so we do try and be present. But that does increase others' workload to release those people from the floor. But it's a priority.
Yeah, thank you. Now, I'll open the floor for the questions from the audience. Yeah, please.
Hello, Martin Hawley from Airspace Unlimited. Helena, I just want to say very quickly, thank you for raising that point about the training, stopping training, and because it just drives everyone in the industry crazy. And I think it's maybe because the finance director in NSP is there for 5 years, everybody else is there for 30 years, and they just don't get it. About 25 years ago, we discussed in the cockpit, so the same sort of discussion we're having today, but it was about the cockpit. And the view of the cockpit of the future was you'd have a pilot and a dog, and the dog would be there to bark at the pilot if he tried to touch anything. And the reason I'm putting this in your mind is because in the context of sustainability and reducing fuel expenditure by airlines, the controllers are very willing to give directs to pilots, and pilots are still asking for directs. But the flight plan might say differently, and the flight plan might be the best route for the airline. And so in that context, I wonder if the workstation of the future is a tactical controller and a dog to bite them. So maybe Roberta might have some good insight on this as well. Thank you.
Thank you. Great comment. Yes, and in effect, Elena, the future controllers should be also well aware, not only about the separations management, but also about the whole life of the aircraft, the ATFCM aspects to avoid the, let's say, the unpredictability of the flights, the overload in other sectors. This is something that is under discussion every time here in these rooms. So please.
Yes, thank you. Thank you for that comment. Oh, I'm sorry. Yes, you raise a very interesting point about directs and whether the main goal is to save time in the flights, but we know that it isn't now, right? Because the airlines actually value predictability over arriving at the gate early, because if you arrive at the gate early and there's another aircraft there, that doesn't help anybody. So that is, I believe, slowly entering the minds of the air traffic control body, but it needs to also enter the minds of the pilots who are, in my experience, most of the time looking for a direct. But we in Europe, we do something over the summer where we actually, the Eurocontrol goes out and asks all the ATC stations and centers that everybody shall fly as planned, because otherwise the system will collapse. Because you know what happens, that if there's too much pressure on one ATC sector, and airlines or individual pilots may think that they can, okay, if I reroute my flight plan in air, if I ask for a different level, maybe I can fly by, under or over that restriction and save the time. But since aviation is global and we're all one big cobweb. And if you tingle up here, it's going to have effects down here. So then that sector over here will get overloaded because that wasn't planned for, that all these aircraft that were supposed to be flying here would fly there. And I think it would be interesting to hear from, I mean, I've heard it, but maybe for all of you, from Eurocontrol, a comment on how that works in the summers. As far as I know, things work quite well when we do this fly as planned. And maybe that's also something then that we need to look at more times than just the summer, and in some parts of the world where traffic is at the moment too congested due to war reasons.
I don't know if there is anybody from Eurocontrol that wants to comment on this, but I can say that Eurocontrol is tackling this. And there was also a webinar 2 weeks ago about discipline flight plan with airlines talking about this. So it's a hot topic under the umbrella of Eurocontrol, and everybody's aware of this problem. Yeah. Any other question? Yeah, Victor.
Hi, everyone. Victor Jegasits from Eurocontrol, Maastricht UAC. So I'm a controller as well, still every day doing the job. And if I might react a little bit to your question and the disciplined flight plan execution. So yes, controllers do use directs. We don't use them for fun. We use them to solve conflicts many times, because that's your solution to your conflict, to send somebody direct. Also, in this very room, I asked many times when we had 200 people from airlines, please put up your hands if you don't want to fly a shorter distance to your destination. Nobody put up their hands. And it's very interesting to watch that disciplined flight plan execution webinar from Eurocontrol from 2 weeks ago, because Anne, who's an Air Portugal Airbus 330 pilot, raised a very, very, very good point that everybody should keep in mind. And she was saying, when I fly from Portugal to Brazil, I have a 10-hour flight, and I want to get there with as much fuel as possible to not to limit my options, because the destination aerodrome might be closed. I might have to hold. So I will take whatever direct you can offer me, because I want to get there with as much fuel as possible. If I get there with my long routing, I might have 1 or 2 goes at the destination, and then I have to figure something out, which might or might not work. And we keep forgetting this, that the pilots still have to land. And I invite Carlos to reflect on that, because yes, there is a money aspect for the airline to burn less fuel, but there's also a big safety aspect of how you get there. And I fully agree, yes, everybody should stick to the plan as much as possible, but let's face it, the plan is a plan. It's like in the military, you have a plan for a battle that goes out the window the first moment you're in contact with the enemy. So once the aircraft leaves the ground, you cannot stick to the plan. We see about 20% of the traffic in our airspace, which leaves the airspace at a different level than what they filed, because they're not able to climb to that altitude. So it's a very tricky problem to solve, but yeah.
Could I just very, very quickly come back on that? My question was about sustainability and fuel use, not about congested airspace. And if you give a director as a controller, you might actually be giving them a worse and less fuel efficient route, because in the control room, you don't know what was behind that flight plan, the winds, etc. So that it was really a sustainability fuel use question.
Yeah. Any other question? Yeah, please. Yeah.
This is maybe separate from the last question, but related to your last question. And it might be a bit of a rambling. So I totally agree that the ATC should be in the loop for new automation, and I think data is king. But at least in the US, it's impossibly hard to see into a tower, get into a tower, get the data from a tower. So as a researcher, I find myself often just developing solutions in the blind and then presenting it to controllers when it's already mature, which, as we've talked about, is not great. So yeah, I guess what are your thoughts on how we can lower that barrier and make it easier to see into towers, get into towers, access the data from towers?
Okay, I'll try to answer. Okay, yeah, in Europe, for example, there is a SESAR JU, who is coordinating research and innovation projects where universities are allowed and are part of the projects, and so they have access to this data with the aim of the project itself. I suppose also in the US there should be some R&D body or it's coordinating this kind of activities and let you be part. And then apart from the body of the research and development, also the FAA could sign a specific contract with university to allow you to get access not only to the facilities but also to the data. And now the data are the most important things for you, I understand. We are working on many projects about the digital, the artificial intelligence and machine learning tool in support of the humans, in support of the controllers. But without the data, you cannot develop anything that is feasible. I hope I answered your question. Just to, maybe you have to push a little bit this kind of collaboration with it. Yeah, please.
Hi, I'm Okwadi from Zurich University of Applied Sciences. I wanted to echo, first say something that's been said many times this week. I think ICNS is an awesome conference, but having so many people, I've talked to a bunch of air traffic controllers this week, spent a while talking to Victor yesterday. It's super insightful for us. I'm a researcher. I've spent 8 years working on RMP. I chair the EUROCONTROL committee on RMP. Victor told me yesterday that he gets scared when pilots want to fly RMP. I didn't know that. And I think I would like to invite controllers to join our conferences, and I'll try to join some ATC conferences if my boss is willing to pay for travel. Thank you.
Thank you. I don't know if there is any other question. Yeah.
Paul Rue Satorth. I hope I don't throw a cat amongst the pigeons here, but I heard a term last night, AV linguist, and I thought it was pretty prevalent and required from an ATC perspective in terms of understanding. So my question here, and probably from Carlos's perspective initially, is the involvement of the user in the design of the end result equipment. And I think what I'd like to ask, hopefully not a roundabout way, is how is that possible? You know, at one stage, you know, everybody says, please let me win the lotto and meet me halfway and buy a ticket. So do you have a list of requirements as ATCs and future functional ATCs from a new generation equipment perspective? Do you have those forums? I'm not a degree qualified engineer. I'm a QBE qualified engineer, qualified by experience, and we'll design you anything. The problem is do you have a list, early implementation and early adopters, and how do you mix those two without still having the capacity to do your work as an ATC? So maybe it's a slightly awkward question, but I think somewhere along the line, if you've got a list, we can design for it.
I can only answer the part that I'm sort of a specialist, which is in human factors. I'll leave the rest, the ATC, for my colleagues. So I cannot give you a very specific answer, otherwise we would be here for a long time. It took me 2 years to do my master's in aviation human factors. Yes, if you consult a human factors, such as myself or anyone else, there are guidelines for human factors is actually part of engineering. So it's actually part of ergonomics. We are actually classed as from an engineering background, even though I'm not an engineer. But when we talk about a human-centered approach and we use a human-centered design, what we do is we put the human in the center. We begin from the human. So, for example, I was thinking about if somebody would have asked me that question, how would I have been able to explain? So I'll take you back to the basics of human factors. So what is human factors? Because we speak a lot about that and a lot of us don't know. It's very simple. It's just about us studying all the abilities, limitations, being aware of the abilities, limitations, also psychological factors that leads human behavior about the human, and then start from that, designing the systems around. Why? Because we want that the systems are working properly, not just in terms of safety, but also performance and optimization and well-being and all of that. So the human has to be in the center of the system. So when you start designing something, we should think about all those abilities, all those limitations of the human, and then do perhaps risk assessments on what can go wrong, how can we mitigate these, or how can we mitigate that. So there's a huge set of guidelines. If you consult, as I said, anybody in the area, they will be able to provide you models and all sorts of different guidelines, as I said. But I wanted to give you, for example, an example which is very close to the work that I do. So as Luna said, I've been working with CPDLC, both in the flight ops management of my airline as well as here at the STM for already 4 to 5 years. So we sit in many meetings, me together with people like Victor, and we speak a lot about the problems we are currently having with CPDLC. And I'm choosing CPDLC because it's something quite basic for everybody to understand. And it's been already implemented for several years, so we know the issues. And recently, I actually co-chair not the OFG, sorry, the DSG. And we spent so many hours, both at the OFG and the DSG, which are, for those of you who don't know, working groups that we have. And we've been spending lots of hours tackling different issues that are arising from the technology not working, such as how do we talk to each other? Do I press Wilco? And if I press Wilco from the message that Victor or Elena sent me, do I wait? Do I action that immediately? No, he wants me to wait, but Elena prefers me to continue. One is expecting something, the other one is expecting something else. And in the meantime, I'm in the aircraft, time is flying, and I don't know exactly what to do. And this all came because the technology, although very good, it's still not offering us what was designed for. And I often sit in these meetings and I think, surely we should have thought about this before, right? Because this was a technology that is being used by myself, Elena, Victor, Luna, and yet probably it gives me the idea that it wasn't thought about that before, because otherwise we would have had mitigation risks and plans in action. So we are now spending all these hours, which is good with a lot of people, but trying to mitigate and tackle problems of the technology not working. And we now need to decide how we're going to talk to each other when these should have actually been done before. So in my opinion, as a human factors expert, I don't know what the work was done before, to be honest with you, when the technology came up. But when we have an idea, and this is for the engineers here, and you want to researchers as well, and you want to do something, I'm a researcher myself, then you have to think, okay, if it works well, this is going to be very good. If it doesn't work well, what are the risks? So the technology doesn't work, there's going to be latency. How are these two end users going to be talking to each other, not afterwards? And I hope, and this is what I've studied, that if you implement all the structured guidelines that human factors experts have in designing systems, then perhaps this would be tackled way before. Sorry, I didn't want to go on so long.
Elena, I don't know if you want to complement.
Yes, sure. So I think that we need to all work hard on convincing air navigation service providers and regulators and airlines, et cetera, that even though there's a shortage of humans in the system at the moment, humans are one commodity, money is another commodity, and no business would consider not investing money for the future, because that's not how business works. It's the same with investing the human capital. You will need to extract a number of man hours, woman hours, to invest in the future. And for the part that this is not possible and it can't cover everything, I think that events like this, networking is excellent, because getting to know each other, sharing business cards, that means that you can call me or somebody at IFATCA. That's why we're here, to sort of make a presence. We're also involved in ICAO. We have a presence at the Air Navigation Commission. We sit on 12 panels. We are currently chairing the separation airspace safety panel. But there are many ways to involve each other, I think, and networking is probably the cheapest. So this is a great event for that.
Thank you, Elena. Last question, and then we'll close, please.
Thank you. My question is specific for Roberta. I find it particularly interesting that you're both a pilot and a controller. And so from your perspective, you know, as I'm only a pilot, so I can only see one perspective. And I hear people say, oh, I wish, you know, controllers had this and that, and controllers say, I wish pilots wouldn't do that all the time. So from your perspective, what are the biggest challenges that you could tell the other side? And then from your perspective, what would you recommend to equipment manufacturers to address, or the system in general? Doesn't have to be the system itself, it could be the procedures and the operations. What's the top challenge in your view, having seen both sides? And for background, my name is Hannes, I work for CGI, which is a big systems integration business, and we build secure, assured, mission critical systems for aerospace solutions. That's the background.
Great question. And what I've learned is, although we think we know what's going on the other side, we really don't. I think coming to United, I didn't realize, you know, when I get on an aircraft now and I depart on time, my bag is there, we're safe, efficient, I'm amazed. I am still amazed that everything worked because I know what's going on in the flight deck. I know what the controllers are doing. I know what our network operations are doing. I know what the bags are doing. You know, it's still amazing. And I think understanding each other's other side of the business is the only way to make it better. We welcome anyone to come and visit our network operations, our ramp towers, our SOCs, because that's really the only way to understand what we do in our business and how the other side impacts or helps us in our business. I think another challenge is almost like data definitions. FAA defines a delay differently than we do. Our delay occurs 1 minute after we're expected. If we don't depart, you know, block out on time, etc. FAA has a different definition of delay. So we measure things differently as well. And I think if we talk globally, that just adds an extra complex because I know we're not talking the same definitions and understanding the same foundation. So I think that's a challenge too, that I don't know if we talk about enough. We just accept it, but is there a way to change it?
Perfect, thank you. And sign me up, please.
Okay,
I'll take you up
come
on
on
that.
over. Thank you. So we'll close this plenary 6, last plenary. The key message is that next year for the CNS conference 2026 and onwards, the human rule will be tackled in plenary 1. So, so I'll give the floor back to Nikos, and thank you for joining us.
Thank you, Luna. Thank you, Kostas. Thank you, Elena. Thank you, Carlos, and thank you, Roberta. I think that we have achieved actually with this plenary a long-standing goal of the ICNS conference to bring pilots and controllers in our conference. And I think this is something that Okori actually mentioned. I think that maybe the traveling issues, I don't know what is the problem. We have been trying very hard for many years now to bring the view of the pilots and the controllers into the conference because we really believe that the end users need to guide these things. That has been very difficult, so we're really proud that this year we're able actually to have this excellent panel to provide this view, and we do hope that the managers will be convinced to continue investing in this thing. Because really what the ICNS is really doing is really bringing two worlds together. I think that the afternoon part is the technical part, the researcher part, and we want them actually to be unlimited in their view, to start coming with ideas without being contaminated, but what we think it is a correct way to do it, the operations. Then if out of this 144 papers, with the people that they know the business, the industry, all the regulators, all the people that they know how the business works. If we have 20, 25 papers that they really make it to the field, that will be a great success. And this is what we want to do with this conference, with the networking breaks, with the morning plenaries and the technical part. So this is really a big, important message that all of you it is important to have. And for example, we very much value that the time that Pascal is taking, that is coming, is staying with us in the coffee breaks, is discussing with the people, giving the international perspective in all these things. So really a big thank you for that. So we're coming closely to the end of the plenary part. So what can I say? So I will start maybe with, I was trying just to think, to go through the program over the different 3 days. And I put some keywords actually that I had in my word. So maybe I will put, maybe if we can blank this thing for a moment. So I was just thinking, what are the keywords that I had from these discussions? So I think I put collaboration. I think that was really discussed a lot of times today. So we really need to collaborate. There is really a global dimension of aviation, and we should not forget that one. We also need harmonization. Then I think it is also important, and it was highlighted very appropriately, that we need to keep the human on the loop. So it needs to be a human-centric approach, but at the same time, integrate the I from the conference, integrate automation, integrate new tools, integrate evolution, integrate new concepts. Then I think that there were also a lot of challenges. And what is worrying is that the challenges, instead of getting less, may be becoming more. But what this tells us actually is that we need to adapt, we need to prepare, we need to anticipate. I think it was mentioned sometimes that today there is a new norm, and we don't know what the new norm will be tomorrow. So this is where it is important that we try to see how the technology, because technology is not the problem. Technology, CNS technology can offer solutions to problems. What it is the problem for me is sometimes the lack of any strategic vision. When I started in 1995, not coming from the aviation, I came to EUROCONTROL. I was told that, Nikos, VDL2 is going to be widely deployed by 2000. And your job is to define the next generation communication system. This is when we discussed about FCI. We started dealing with different technologies. So now 2025, I think that we're having now the VDL2 a bit relatively well implemented. But still, I think that we are not having a full evolution plan on the data link, which is a critical enabler. So we really need to have a strategic vision and stick to that one. We cannot change every 5 years. There is a new concept coming. Let's consider this concept. I think that we have done that too many times, and we have not learned the lessons learned out of this activity. What we need to make sure is that evolution, we provide evolution proof in this domain. And again, I repeat, technology is not the problem. People are using technology to justify financial issues. And this is where I want to come actually. So the big problem is actually incentives, investments. So the investment is really the key issue. And we need to find a way to bridge the technology with operational benefits. When I started, there was a sentence that somebody was mentioning about CNS. So what does CNS stand for? So what it was told, that was in 96, 97, I believe, it is costs, not services. So I think that I have not been hearing that expression for a long time, which means that I think that people have stopped thinking so much on that one. But really, we need to go on this direction, that we bridge the gap between CNS technologies and CNS services, because this is what we want to have, CNS services that will bring really the benefits. I think I talk a lot, and what I want to say is that behind these 3 days of event, there has been a lot of effort, a lot of collective effort. So what I would like is to take some time to go through some of the names. There is, first of all, the organizing committee of the ICNS 2025. So this is really a group of wonderful and amazing volunteers that they have been spending doing the day job and also spending the night time to do other things. So really, it is I'm very grateful, myself and Brenda, for the technical program chairs, so Rainer and Paul. The plenary program chairs, we have Christian with us somewhere here today, and also Sherry. There is the sponsors and exhibit chairs that allowed us actually to have this wonderful conference financially. So we're having David, we're having Christine, and we're having Anne over there. There is also on the finance, Denise is somewhere around here. Then Michael and Alok on the awards chairs. We had Lanseri and Gian Carmine on the student awards. We had Alexis, which is the one person that we have seen, all of them. We have communicated a lot with Alexis, so she's on the reception desk. Then also Christine helped us a lot with the local arrangements. There is also the communication from Raphael and also Job Banks that has been really doing a great job with the web and email communications. Kathy helped us a lot with the graphic things for ICNS. And also Alok Roy is the ICNS Executive Committee Chairs and the DATC Chair, Mark Darnell. Then, and I think that will take, I will not go through a lot of things, but we really had the host planning team. That was Paul, that was Veronique, that was Predrag, that was David, that was Christian, that really, and also Lucia, that really helped actually in supporting in the planning of this event. We had really a great support from the Eurocontrol corporate communication team, and even and also very great support from the conference support team. So I want to say a big thank you, especially for those people. So what I try to highlight here is what happened over the 3 days. So we had 3 welcomes, 4 excellent keynotes. We had really 8 plenary session chairs with 6 plenary sessions. Then we had 26 plenary speakers actually over these 3 days. We had 144 technical program presenters, 12 track chairs, 40 plus session chairs, 60 plus creators of these papers, and more than 400 authors. So these 144 papers came from these 400 authors and researchers, and more than 350 participants. We have more than 2,000 views on the live stream and the playback. And most importantly, it is actually you. I want to thank you for all the discussions, for all the exchanges, for taking the time to be with us. So I think that we have reaching the end. So really also a big thank you goes again to our sponsors. So really thank you very much for enabling also the logistic aspects of this conference. So I'll just make one more thank you to them. So we are not finishing. This is the last plenary. So there is an excellent continuation of the technical program. So we're having 6 rooms that they will be used to provide very interesting papers. As Rainer will say, which I don't see him now, so we're going to start sharp at 3:30 with every 30 minutes changing. And we'll be finishing today at 5:30, which is the last paper that will conclude the ICNS 2025. So we ask you to put in your calendars the dates for the next ICNS, ICNS 2026. And I think this is really the 14th to 16th of April. The plan is that we'll go back to Washington, D.C. in the Westin Dallas Hotel. So that's we look forward to see you there. So thank you very much and have a safe travel back. Thank you. And a big thank you to all the people actually that they're watching us on the live stream. So thank you very much for your patience on that. Thank you.